This is my first time I'm here and I work in ULA. It's
You work in?
ULA, ULA. It's a B2B Indonesian startup.
Okay.
Yeah.
Thanks. Here, yeah, bring the mic here probably. A bit of running in the morning.
I'm Anjanelu. I'm a data scientist at Reliance Jio. I work for the computer vision team. So this is my first time coming. I just relocated 2 months back.
Reliance Jio. Okay, I think your neighbor.
Hello, I am Varun Sonwani and currently I work in Convert, which is a fintech startup, and I am here for the first time, so pretty much excited for the event.
Here.
Hi, I'm Vikram Chaudhary. I'm working at GE Healthcare as a lead system designer. I have around 15 years of experience. I use Java and .NET in my tech stack.
Most used middleware. Java and .NET. Thanks, Vikram.
Hello friends, I'm here for the first time and this is Amit Agrawal here and I work as an architect in Octave and planning to build some large scale applications, doing the right kind of deployment. Thank you very much. I wish for the same.
Yeah.
Good morning to all. I'm Mallikarjun from Emerson. I'm a developer. Just I'm an explorer to Meetup. Thank you.
Thank you. Anyone left or introduced to this community? You?
Hello everyone, I am Mudita. So currently I am working as a developer at Delta Airlines and I am attending in person for the first time here.
You joined remote, is it?
Yeah.
Oh, super. Thank you. Nice. You introduced. Anybody left? Don't be shy.
Hi everyone, my name is John and I am working as a software engineer at Cisco.
Cisco. Great, thank you. Yeah.
This is Srinivas, working in Yahoo as a DBA.
Working in?
Yahoo.
Yahoo. Okay, great. Known faces? Yeah. Oh, this is Mintra. So Mintra crowd is in the back benches. I don't know why.
Hi, I'm Pooja. I work at Myntra and this is first time.
Super. So would you be tracked to the other location when the next event happens?
Yeah, why not?
Super. Thank you. Please.
Hi, I'm Chanvi. I work in Myntra as SRE and I'm a fresher, so this is the first time I'm attending this event. So really excited and looking forward to it.
Super. Thank you. Anybody left? Good. Shweta. Why Shweta is shy?
Hi, I'm Shweta. I work at Myntra as SRE and looking forward to this.
So let's bring Shweta to the stage to introduce our keynote speaker from Myntra. Go ahead and introduce him for the keynote today. You know? Okay, so I myself will hand over the mic for the keynote, please.
Hello? Yeah. Hey Shweta, you could introduce me, you know who I am. So, anyways, so first of all, welcome to all of you to this event and secondly to Myntra. I think we are hosting it for first time, so I really want to make it a very kind of interactive session and event. I hope you enjoy the things which are coming forward. First of all, I was very glad to see this vibrant community which has developed over the last 10 years, grown to 3,000 plus, which is a big feat, and thanks to the organizers who kept it alive over the year. This function, as you know, is a very, very important function for any company, and coming together as a company, everybody has different challenges because the company's models are different, right? So you solve so many problems when it comes to scalability, performance, resiliency, this, that, whatnot, right? Dealing with cloud, non-cloud, multiple environments. And there is uniqueness in every company. You come together, share your learnings in this forum, boundaryless, without recognizing company boundaries. just seeing that is a kind of a great thing, right? So learning from each other and being here, and I'm sure that this community will develop to multi thousands because this area is getting complex, and that's what I'm going to talk about. So with that, I will not kind of talk about SRE that much because you know your job much better than I do. I'm pretty sure about it. What I will kind of talk about that what I see from my perspective, that how this area is developing going forward and what are the things which might come, and these are just thoughts. So you can extrapolate that how it will impact you. I don't have a prescriptive way to kind of say that this will happen or that's where we have to contribute, but I will kind of say certain 5 things which I see happening. So first of all is developer productivity or developer automation. That is where the whole thing starts, right? Though production engineering is seen towards the end when you deploy the code into the production, but not, I mean, it starts much ahead, and it starts there, where the term called GitOps, which has come into work, and where you are kind of saying that how the developer productivity is increased by automating certain things, building CI/CD pipeline, building multiple deployment models, integrating with cloud, the cloud deployment models, whether they are on Kubernetes or they are on VMs or wherever, and the list is endless. Now, on that, the new thing is get added is generative AI. Now, I don't know how it will impact you all, it will, because when you integrate that code which is generated by generative systems like ChatGPT or Codex, actually Microsoft is already integrating Copilot into their GitHub, right? So that is going to be part of it, and how you guys will address where the wrong code or things don't go generated and directly get incorporated into this. There are other opportunities which are positive side, right? Code documentation, code reviews, automated, right? And all that. So there is opportunities are endless, and this will get into your pipelines when you get and on top of it, we talk today hundreds of deployments per day, right? Continuous deployment, and that again that is boundaryless, right? How many deployments per day one can do realistically, and but that is with all these technologies coming, with maintaining that kind of model is a huge challenge. That is one. The second thing is cloud itself, right? So cloud deployment models are becoming stabilized now. I think everybody in this community must be working on some kind of cloud deployments, but the challenge is not on single cloud, on multi-cloud deployments, hybrid cloud deployments. Combined with that, because you want to build a resilient system, you want to build a BCPDR kind of systems, and that is where the DevOps role is so important to make it automated, where you either it is a single cloud, multi-location, multi zones, where you achieve that resiliency, and cloud providers provide that model for themselves. But what about sky computing? Right now, people are going above cloud, right? Because these clouds are changeable. You can put your workloads on any of the cloud and hybrid cloud, and those deployment models, which provide a different kind of challenge. Another thought to kind of take it back from this and start considering which is going to be future. Third thing, what is MLOps, right? So MLOps word till now, it is very much into the data science domain, right? But what I see that model deployments are such an integral part of any application, because every steps, at least we see in our applications, that many of the things are driven by the even personalization and stuff like that when you go to any website or e-commerce site, or there are various other things. The model, the predictions are part of the whole application deployment. Now, MLOps can't exist in isolation. It has to come together and deploy in general. Now, what is so unique about MLOps? All of you know, right? So this is two distinct parts: training, and then which is akin to code development in the conventional world, and then deployment, which is akin to deploying that for scalability, resilience, and whatnot, right? But what is unique about MLOps is that it is not only code, it is code plus data, right? And the development. Then deployment, it is very different. It is integrating the pipelines, making it scale, because the predictions which happen in the testing environment are way low in scale than what happens in the actual world. Then whole observability of that. Their observability is the classic observability which you have, But then there is the observability of models itself, right? Whether they are performing or not, where are they going, all that. So still, good part will remain with data science or I would say the data science engineers. But then there is a whole area of MLOps, which is coming closer to DevOps, MLOps, whatever you say, it is one deployment, right? So that. The last one is, I would see this observability. Observability are there, we have it, we integrate it, but the whole model of security and observability, I said both. When you do deployment, integrated security and integrated observability. So it is by default, it is not the afterthought. So when you do your logging systems, etc., they scale to the same extent your application is scale, and it is together. So and integrated, right? So all the metric generating system as well as the logging systems they generate, and then on top of it, multiple opportunities to use AI not as a deployment, but AI as a kind of engine on top of it to auto-tune many things, right? So because that is where the data is collected, data is there, hundreds of parameters. Why not? And some of the things which we are adopting, for example, I will give you an example. In our system, we are using ML to predict the traffic for our testing, because when the sales period come, we distribute load across machines and test it for different modules based on the previous patterns, that what will happen for the predicted load in upcoming quarter. If there are 5 million customers going to come on the next sales, how do we kind of even test our system? So use AI for that. So that is another one. So I was just leaving these thoughts behind and see these are some of the newer areas or emerging areas which are kind of getting integrated as part of what we call production engineering, DevOps, whatever you call it. There are multiple names, but that. So with that, I will kind of just leave and let this forum continue. I think there are many interesting topics over here which kind of clearly complement all that. You guys are talking at very implementation level and architectural level. I am not talking at that level, but I'm sure that you can take these and see that how it applies to your domain. With that, I thank you all. You have a great session and the day ahead, a learning experience. Thank you.
Thanks, Ajay. So when Ajay started, he said, you know SRE better, but when he actually spoken, he has talked about the ages of SRE, including MLOps. So it clearly says how grounded this person is. Thanks, Ajay, for joining us today. Good morning. Okay, so I'll now invite Mitesh. Mitesh is our first speaker for today. He's going to talk about, once again, a very challenging issue with cloud and EKS. Where do you keep your secrets? What's the best practice to manage it? Mitesh is well known in this community. Multiple talks from Mitesh. He was lastly working with Fred. So now working independently. So back to you, Mitesh.
Hello, welcome all. So I have been giving talks regularly at LSP. This is my fourth talk, and I would like to explain here some initial thought process if we go into some architecting and designing of any software. So just it looks very simple, but it solves some things very elegantly. That is what today's topic is. So is the slide Ashu? So meanwhile they are bringing the slide, just I want to tell you about when we were starting at CRED, so we were thinking how to send the secrets. So I'm just telling a story. So we thought of using AWS SSM parameter store, and what happened in UI, AWS UI, it was working with ECS task definition. Okay. I'm fine? Yeah. Okay. Okay. So what happened then, from UI it was working, but we want to automate it. So we tried using CloudFormation, and there we found out that it was not implemented. So So that limitation became blessing in disguise for us. So this is implemented using a simple Python code initially, and injected environment are injected at time of when container starts. Okay, so is our slides visible? In that way, we were able to automate it, and it solved a lot of problems. It's fine. So I'm presenting here today secret and configs in ingestion in containers at the runtime, so that it becomes compliant with security. We are not storing credential on file system, so it safeguards, means getting certification easily, like PCI DSS. Yeah. Next slide. Next slide. So today's agenda is like how we are injecting secrets in the container which is going to be started, and so what is the need actually, how, why, and how we have arrived to this situation, and why we want to build something. Because I told you the story, but we'll see other things required, why this need has arrived. Second is mechanism, how we are injecting the secrets inside the container. Third is advantages and disadvantages of this approach. And fourth, like questions and answers. So even if you have any doubt in between, you can ask anytime. Yeah, next slide. So why this is needed? Because from early experiences and encoding and development with and like discussion with developers, we found out that generally, like, our slides visible? Okay. Yeah. So we have seen generally like hard coding in service code, like people write directly like variable inside the code. So that is bad practice again. Second, what is the problem with that? Like if you want to change if you are deploying in multiple environments, then you have to go and change code for everything. So that is not, and you have to maintain multiple branches, then code becomes out of sync. So many problems occur with first point. Second point is hard coding the service config in code repository. Again, it gives auditing information like rollback and other things, but still you can't store secret in Git. If your Git is compromised, everyone can see your secrets. Fourth one is hard coding in Docker container. Like at the time of Docker container generation, secrets are injected into it. What are the problems with it? Anyone can tell? So what is the problem with hard coding secret in Docker container? We have to redeploy one in like file in container, say multiple Docker. Yeah, that is. And again, if your repository is compromised, your code goes. Third problem is like for if you have multiple environment like stage, prod, then you have to build a separate containers for every environment. And so you can't say this container is well tested on stage, it will work on prod. So these four problems are there. Fourth one is if someone is using only Kubernetes, they can use like Kubernetes secrets. But problem is you are Kubernetes locked. Means you cannot move out of Kubernetes. Yes, correct. Yeah. So these are many problems. Even if someone can log into machine, they can see all even it is not related to the service, you can still see other services there also. So due to this problem, we thought of like avoiding all these things, and we are not like logged in into Kubernetes. Like we can use ECS, Docker Swarm. So that are the advantages. So some advantages like we have single container because we are building only one container, deploying stage, prod, and since variables are coming dynamically at runtime, so we can use same container. So it helps us in like highly well-tested container in stage will go to prod. So second point is about that. So we can do container promotion and no surprises in prod because we know this container is well-tested. So only if variable is not good. So that also, like say there are 4 variables in stage and say we forgot to put fourth variable in prod. That also will be caught by this system. So that is the advantage what we got. So no surprises in prod. So if it is well tested in stage and in pipeline, we check the number of variables and is it present and populated or not. And secrets here, secrets, whatever developer wants, those secrets will means it is audited. So they, like I said, 4 variables are there. It means it is coming from developer's code that they want these kind of variables stored in these paths. So in that way, it becomes easier to like audit information. Say even say we are deploying in blue green. So say new variable, there is 5th variable in version 2 and V1 is deployed already running. In green stack, we can test the version that extra variable also. So in that way, if it fails, if it is not populated also, that failure occurs and your code will not go to production. So it gives those functionality. I'll explain how these secrets are coming. Means, and the last advantage is it is pluggable. So pluggable means today I am using SSM and it is costing more. I can move to HashiCorp Vault easily. Even any other better store comes, I can move. So that is the advantage, and it never asks a developer to change a single line of code. That is the biggest advantage. Next slide, please. So yeah, this is like a bird eye view of the architecture which is used. So this is our secret store, and it is API is exposed. And whenever a service starts, it's init. Say in Kubernetes, init containers are there. They can inject, or we override the entry point. So by overriding entry point, we are injecting the variables. In that way, many advantages occur. Like our images are logged. Say some upstream image is there, and say it is available today. Tomorrow that is removed, but still we are having our own image because it is logged. So no problem will happen in future also. So this has saved a lot of time when Docker hub is down. Any bug happens or any say network traffic or throttling does not happen, reflect here. So that is the advantage. So any question related to this slide? Yeah. So that authentication, so say this container is running on one machine. So there one role is attached to it. So that role brings, is having permission to access those secrets only. Yeah. Yes. Yeah, means data is accessing the through metadata API. Yeah. Yeah. Yes, chicken egg problem. Yeah.
Everybody asks is, how did he compile that compiler?
Yeah.
And he did accept the fact that he did use a commercial compiler to get that bootstrap done. So that's the question. Like,
so here also I face the same chicken egg problem, and I solved it by like, so our code runs as an entry point. So it access through that role, acquiring that role and fetching the secret what is developer is providing. Means whatever secrets he wants, then on those only secrets are brought. So
Point we really need that some manual intervention.
so chicken means if he says chicken came first, so that chicken is a role, instance role. Yeah. 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 Even same problem we will face with Hasik or Vault, because it also requires one secret to fetch other secrets. So that, yeah. So again, here I am solving it by like fetching that secret from SSM and then fetching other secrets from Vault. Yeah. Yeah. Key. Protected. Yeah, and rotated. Yeah, means with role-based that automation is not required. If we are using key, then we have to keep rotation logic of key we have to integrate. Yeah, role is like automatic. When we create cluster, we are always attaching that role to instance in the. Yes. Yes, infrastructure layer. So in that way, that headache of like rotation and everything is taken away from developer. Next slide, please. So yeah, this is like a rough like configuration which developer provides. You can change it accordingly because this code is written by us. So you can see here configuration is given and service name is injected and run environment where they want to deploy. And these are their variables like DB name, password, host. So they are unaware of what these are going to be because these are injected by different database team. And if he is accessing some service, he can access based on keys, access key, secret key. Those can be rotated outside of the system. But just for example, I am showing this. In this way, we know they cannot bypass the security, and all what they are accessing is already documented in their Git. So code review is done before like any actual deployment. So we know that every service is only accessing their variables. Service name, say my service name is Spring Boot. Yeah. These are just path, but in the end, the environment variable will have db password equal to some variable, whatever is set by db team. Prefix key is so problem with this every if defining every individual key is that three requests are going to SSM. Okay, to optimize in single shot, say up to 10, you can bring in one shot. So prefix, if you provide prefix, it will bring all the keys given as a subset. One shot, in one shot. So that is AWS optimization. Yeah, so different way of accessing. No. Internally AWS product. I mean SSM is AWS. Huh. No, they cannot insert. It is only read only. Yeah. Yeah, because see, DB team is creating the database. They have to manually store the. Yes. Say like database team has their UI. They create the database and it creates a database and all these variables are generated and their service name, corresponding keys are created in their environment automatically. Yeah. So database creator will put means the software, whichever software or person. So you can put personally also, manually, or via software also. Auto. Yeah. Yeah. So that's what. So separate team have their responsibility. They do on their part. At the end, everything combines and runs. So in that way, developer doesn't know about what my database host name. Even host name is not available. So advantages. So we have seen like if we test. So same we have not even put the service name and even the environment. So same set of keys will go everywhere. So same if container is also built with same code, it will remain same and we can use in stage prod, even pre-prod, wherever you like. So and it can be tested in CI/CD also. Same container because we create only container once. Means your binary is built means Java, jar or var is built only one time. So that is the advantage of this. So you never say that my jar is different in stage and different in prod. That is the advantage. Second advantage, I am agnostic of any cloud orchestration, means container orchestration system. So in CRED, we have like migrated from ECS to EKS in one variable, means developer defined just one variable and the whole deployment from ECS moved to EKS. So that is the advantage without any concern related to like whether my deployment will succeed or not. That means we can use Docker Storm also because it is not as a part of actually their system and we are not using any. It is just container when at the start it runs and fetch the environment will inject to the environment of the service. And it is simple to envision by DevOps. As we have seen like it is, so even know just you need to learn one system rather than multiple system. And it is pluggable. As I told it, we have tested with AWS SSM parameter store and HashiCorp Vault. And it helps in locking the base image. As a security perspective, it means it brings security as a second order effect, but it happened for us. So because our image is locked, so we know that even though upstream image is changed, it won't affect. So say I use, for example, I just use Ubuntu as a base image. And say if in future, say 10 days down the line, if it is updated and it has broken some changes, then our deployment won't fail because in this image, we have actually overridden that image and with our entry point. So that image is logged. So the layers are stored in our servers rather than it won't bring the images from Docker. That is the advantage. So This helps a lot because sometime even some image you are using and it is deprecated by its own developer or owner of it. So that is the advantage. Any question related to this? Okay. No, just an example. Yeah. Yes. Yeah. Yeah. Yes. Yes. Yeah. So we have studied did comparison between Alpine and so we generally use Debian, not Ubuntu. We did comparison between Ubuntu, Debian and this Alpine. There are some breaking changes related to libraries. That is one problem. Second problem is like some Java projects require compat library. Then again, it makes it much slower at runtime. Then, so due to these two things, and also if some things are well tested with Debian-based library GCC. So these three things have made us to decide on in favor of Debian, and we use Debian as our base images. And it makes things like simpler. Even if we change base image, that if some developer has written Docker file, it won't break. Otherwise, things will break if we use to switch between these two. Yes. Then it is good. Yes. Even ephemeral containers are good in Alpine. Yes. Yes. Not all. Means whatever variable they are defining, it is related to that service. Not they cannot access other service variable because they are defining what they want. If you are defining means your code, you will say if you have bad intention and you are going to commit it, correct? Devel ah, yeah. No, no. How about who is approving your PR? It matters, na. If it is going, so you are having some process, correct? No, 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 that is. So say if you, so after accessing this, we relinquish all the secrets from our side. So even someone tries to to go through that metadata, they can't. First initial entry point we have access, after that we remove that role from that. No, in SSM you can store in plain text or keep it encrypted, but directly. That's why I told it is not dependent on Kubernetes at all. It is just inside your container, it runs as a first service, and after injecting the variable to means handing over control to the actual process, Java minus jar. So at the time, those variables is injected in its own that environment variable, and it relinquishes the control. Yes. No, no, no. So due to that, some problem comes. Let us see the advantages, disadvantages. Ah. So that is the disadvantage of this system, is that it relinquishes the control after that. So there are other way around, but it makes your container bloat. But there are way, like you can run as a agent, and then it will fetch and store in file. Because if you are refreshing, then you cannot take it from environment. Then you store in file and re-inject those variable again into your code. But makes it bloat. So there are ways, but we are not using it because we don't want to store the secret in file system. Next slide. Disadvantage. So not this is the disadvantage that we are talking about. Like we cannot refresh the variables. Only like once the container restarts, then it will fetch the new variables. So that is the disadvantage. Yeah, it is having versions. But if you notice, there is versioning information in the path. So even it is not having, we are not bothered. We can have multiple versions of, even the versioning is not supported. So that makes our code, we can roll back easily. Because we are in V1 is used in version 1 of our code. So V2 of secrets are stored in V2 of our code. If we find V2 is not working well, we can roll back and V1 variables will take. So that is there in path. So it is designed, path is designed in such a way that we can roll back and go to whichever version we want. And no, we are doing. So if we go to the previous two slides. Yeah, here. You can see this is the version. So here we can change V1 to V2 and it will bring V2 version of the. So that is the biggest advantage. Store this means this path in your developer's code. The advantage is that you can bind your variables with your code. The biggest advantage. So you can surely say that my code works with this set of variables. That gives a lot of advantages, while even you can roll back, roll forward. Yeah, last. Yeah, that is. No, not seconds. You can fetch 5 minutes is fine. If you do more than that, AWS throttling will happen, and yeah, that is yeah. And base image needs to be customized just by putting that. And initially, it was in Python. It was like taking more than means putting extra 200 MB around. So moved it to Golang, and it is done in 12 MB. 200 MB because of like all dependency in it installs. Say in Java, Python is not required. So it install all its whole dependency and all those things. So by moving to Go, we saved this space also. Single binary. Yeah, not right, because so we have saved a lot of space. So Rust becomes like if I hand over it to someone, then yeah, I will try Rust. But Rust is memory. That is perspective. Perspective. Don't say this. C is also not garbage collector. No, it is having. It has. Means you can do anything in C. That is the advantage. Yeah, high. Yes. Yeah. Yes. Yes. You have to also think about what kind of people around you they can support in future. That's what. Hmm. Yeah. So here it is like bash, and then inside that go run depends on the architecture. So we are having supporting two architectures. So based on it, it runs a binary depending on the architecture. That any other question? So I would like to answer a question like, do you find this really interesting? Like, could you try to use at your org, and like if you are going to use what is? Yeah, Azure. Yes. Yeah, means implementation. Just you need that very simple program. Yeah. Yes. Plug it. Zig, V, Nim. There are many languages. Even V is similar to Go, and try. And it tries to remove that garbage collector. SRISTA is like acronym for Simple Reliable Infrastructure, Tools and Automation. Yeah, so like I'm founding this company. So it is simple. Thank you. Thank you everyone for attending. Any online user having any question? Online? Okay. Thank you. Thank you so much.
Yeah. Hello. No. Yeah, he's online. He's. I'll just introduce and. Yeah. Yeah. Hi guys. We'll share. Abram will share. Uh,
Kashyap, shall I share the screen?
uh, yeah, Abram, I'll share.
Okay.
Yeah, hi all. Myself, Kashyap, and Abhiram is joining on from online. So we are from Myntra, and I'm a senior software developer in Myntra. So today we are going to speak about our in-house performance tool, which is Skillet. Yeah, over to you, Abram.
Okay, sure. Yeah, go to the next slide, please. Okay, I'm Abhiram. So I handle the test platform tools at Mindra. So we develop various platforms, especially for testing. Am I audible? Yeah, Kashyap?
Abram, can you speak a little loudly? It's voices.
Okay. Hello.
Yeah, you can continue.
Hi. My name is Aviram. I handle the team that develops test platforms for Myntra. And Scale.it is a platform that is used for performance tests. Now, as everyone knows, in the e-commerce gets a lot of traffic every day, and especially the sale times is there is a lot more traffic. So performance tests are have become very much mandatory for platforms like Myntra. Akash, can you move to the next slide? So today we will first, I'll just introduce you about what performance tests are and what kind of tests generally people do to certify their service, and then we will tell you like why we had to come up with such platform, and then we will just give a brief intro about your platform. Scale it just to show you like how the tool is, and then we will just give a brief about the high level design that we have. Okay, and then we will talk about a few tech stack we have used, and obviously there are a number of challenges for scaling the scale it tool in itself, because we need to scale the system in order to test at scale. And finally, we will talk about the cost optimizations that we had to take care of. Yeah, and yeah, so that is it for the introduction. Let me just go. Yeah, yeah. So what are performance tests? So yeah, so basically, hello. I'm not loud. Hello, am I not audible?
You able to hear us, Abram?
Yeah, I'm able to hear you.
It's a little bit feeble. Can you talk a bit louder?
Hello. Is this fine, or I need to be more loud?
It's low.
Hello.
Yeah, you have to be louder.
Okay, let me go. Hello. Is this fine? Hello. Is this fine? Hello. Hello.
Just hold it for a minute. They want a break, I think.
Okay.
No, just call out for break.
Oh, okay.
You guys want to take coffee? Yeah. Request everyone if you want to just hold it, so that
Sure, yeah.
the ventilation noise is done with. Yeah.
Sure.
You can stand there. Okay. Just go to the slide. You know the slide.
Yeah.
What happened?
Guys, Abhiram was supposed to be here today, but yesterday he was injured in a small accident. So that's why he's doing it online. Right. That's why we had this technical. It was not planned. All right.
Hello. Is it fine, Kashyap?
Yeah, you able to hear us?
Yeah, yeah. How is it now? Should I? Okay, my voice is clear, right then?
Yeah, it's feedback.
Hello. Are you still getting some disturbance or something?
We'll start. Yeah. Yeah, Viram, people are taking a coffee break. Stand it. You speak that. It's easier. You know the things, right? Because he is injured. Yeah. So the yeah, sure. Yeah. ये जल्दी हो जाएगा. Done with coffee? If we'll start this second session, then we can. 1 o'clock is the. चलेगा. कोई response ही नहीं कर रहा. He is louder. Actually, we can start. Yeah. We can start, right? We can start.
Hello? Yeah, you're able to hear me, right? Yeah, so yeah, hello. Hello. Otherwise, I can take this. Hello. Is it audible? It's audible?
Yeah, audible online.
Yeah. Can we start? Yeah. So as Abraham was explaining, the use of performance test in our industry. So basically, what is performance test? It's actually something to measure systems scalability and stability and responsiveness under various load conditions. So basically, an e-commerce site like us will be having a lot of load during this sale time and all. So to handle that, we have to have some testing done previously to understand how much load till how much load the system is able to handle. So basically, this is the reason why performance tests are done. Yeah. So what are the key metrics which is checked while doing a performance testing? So one is the response time. So this is basically the time required for the response once the request is triggered, what time the responses got back. So this is one of the key metrics which we check in the load test. So second is the concurrent user load. So this is the till what load the system is able to sustain, or it is the load at which the system is stable. So we need to see at till what load the system behaves properly. So this is the second matrix. The third is the server resource utilization. So this basically is the CPU and the memory usage of the systems. Fourth is the error rate. So there is a percentage of error at which the system is stable, beyond which the system will break. So this is what it is. And then it is the transaction throughput. So it is the so this is the transaction. This is the maximum rate at which the application can process the. For example, for in Myntra and all, if you're adding like 10 items to cart or 20 items to cart, so the system should handle these cases. So these are the key metrics. Now, what are the different types of performance tests? So one is the load testing. So load testing is the testing which is done under normal workload conditions. So it is not a high workload, high load. It is like a general normal load, whether the system is able to sustain. So that is what this load testing will do. So next is stress testing. So you will put the system under a lot of load. So this is an extreme case where to understand the systems where the system is going to break. So next is spike testing. So intermittently you increase the load of the system, load on the system to understand whether under abnormal conditions whether the system is able to behave. Then is the scalability testing. So this is to understand whether the system is scalable, auto-scalable, whether under different, when the load increases, whether the system is able to scale accordingly. And the fifth is the volume testing, which is the same which we had discussed before, like by increasing the number of throughputs to the system, whether the system is able to handle it properly. And then it is the endurance testing. So it is to provide the system with a constant amount of load so that the system don't break in that particular time. Like you are hitting the system with 10k RPM or 20k RPM for 20 minutes, whether the system is able to take it. So these are the types of load testing. And so the different types of load test we do it in Mindra. So one is the first level is the vertical load test. So this is done at each service level. So each service will be doing their test on their particular microservices, and this load is generated directly onto the service. So basically, if it is a product page or cart page, so the cart team or the product team will be doing the testing by hitting their internal APIs with their whatever is the input needed for the particular thing, and load is directly generated on the particular service. And few commonly used tests are load test, stress test, endurance test, and volume test, which I have already explained. Second is the horizontal load test. So this is done at the platform level. So load is directly generated how a user does while during a high load event like sale or something, where user first go to the login page, he logins, he go to the list page, he selects the product, then he go to the product page. So how the user journey is there in the during the particular sale event or at high load times. So it is to replicate that. So basically, the load will be coming at the top of the platform level. It's not on the individual service. Which from the platform it will go to the respective services and to the bottom. From the top to the bottom, that is the how the HLTs are done. And for few commonly used tests are load test, spike test, and endurance test. Yeah.
The question is, you mentioned load generated directly on the public endpoints to simulate user behavior. So basically, it's a different endpoint than which is actually in the production, right?
No, it is the same endpoint, but for when a user, for example, clicks on a product, so from the website, actually the request will be going to the platform, right? So that particular request will be hitting actually.
That because active users are still using the production, right? You don't want it to the public users who are actually using your website, and still you are doing the testing.
So it's so normally earlier we used to do this at the the time at which the users are very less in the website. So like during the night time but now we are on a stage actually we are able to do at the normal time also, but we avoid do it during the high sale, some sale events, or sometimes we don't do it actually, but we use the same endpoints.
Usually, most of the time, Myntra will have a high traffic. That is my understanding. Maybe at the night time it will be less, but during the daytime, if I start from morning 8, 9 to night 9, that 12 to 13 hours will have maximum traffic, and you are testing with the users itself is what you are trying to say.
Yes, we'll be testing with this expected load what is required during the from morning during the normal time only. So earlier we used to do it
Yeah, so I'll answer your question. So thing is, I know from where you are coming. Yes, we are keeping our capacity at that high, and we always want to, like when we design our systems, right? We design saying that it has to take this much request per second, and we always keeping at that level. All right, and most of the time, normal traffic which you get, even at the peak of Myntra, is much more lower than that, and we have extra capacity there. Okay, the testing which he's talking about, right? Usually during the sale and all, the capacity is increased, and then the tests are done during the sale events. But generally, it's like the buffer which you have, most of the systems will have an extra buffer, right? We always put a 30% or 50% buffer there. So the tests are under that. The capacity is there for you to take care of that test which he's talking about. But the sale time which he's talking about, actually the capacity is scaled up, and then the testing is done. That is before the sale event, where the traffic is much like normal, usual traffic. But during the sale, it might go like 4 or 5 times. And it's just that, like, we scale up like a week before, something like that. Make sure our systems can take that load, and during that time, these tests are run. Right? It's like 4 times or 5 times.
So that will be still in production only. So we don't have a segregation currently with the test data versus main data. So does that not impact the business? So so for the orders, actually, whatever orders we are creating for the test orders, so that we will cancel. So apart from that, it will be still there in the production service. So is there a tag in the data? That's not for the yeah, that's the point. Yeah.
Just like how a system works, right? Assume that you have that many unique users coming in and hitting it, and then we just remove it.
Yeah. So actually, currently we don't. Yeah. Currently we don't delete it actually. So it will be still in production, but actually there is a thought like of moving into removing the data, but it is not. We are not doing actually till now. And how do you ensure that
Currently, we are in one DC, one region. We are only in one today, so it's easier. Like I said, when we go across regions, hey, it's a different thing. Yes. Currently, we are only in one. DR strategy? Yeah. We have DR strategy. We are coming up with DR strategy. Okay. We have a DR strategy. Don't worry about that one. Yeah, maybe Ashutosh wants to. Yeah, he has answered.
Yeah. So first thing is that Myntra is mostly in India, right? So we hit from one DC within India or multiple, it does not make much difference. But we had been multiple DCs generating load from multiple places earlier. Uh, but consciously we decided to aggregate. This was not giving the things which we want to test, like ISPs, tier 2, tier 3 cities, right? And after doing it, we are measuring the performance of load generating from other cities via different channel. It is purpose is that for this thing is that our system is able to take that burst which is going to come at midnight. If the objective is clear, then it doesn't matter how many DCs. Yeah. Uh, Interesting. We started this exercise some time back. Possible, right? This market is too much of competition, and then 2 years back, situation was very different. Everyone was competing in e-commerce and thing. So I can tell in generic way that how it can be possible. So if you're using some CDN providers, let's assume something XYZ or Akamai or whatever not, they can have the data. Uh, the SDKs which you push into your iOS and Android apps, they generate a lot of data. They can even capture from the devices the various parameters which you have it, which you can send to your clickstream like stuff in server side and do analysis over there. So it's a mix and match of many things, and very important for anyone in e-commerce industry to understand ISP construct as well when your ISP is one of your competitor. So yeah, so you never know, right? Is you running sale and Myntra running sale same time. So anything can happen. So like I said, it's a combination of many things you have to apply and then work it out. Yeah. Question is well. Geo is one of the ISP. Geo is one of the ISP, but we are not hosting it. Any other question which? Yeah, I think it's a bit deviated one. We can have a chat on the DR strategy and thing. Yeah. Maybe in break we can have that. Yeah. So we know. So how you can do it? Let's put it this way. If this is a question in front of you, and definitely to test the peak load during sale, you cannot build a new system. It's very, very costly. You have to do it here. One thing I think talked about that you create dummy users. Then when you create dummy users, you have an order ID and thing, everything related to the user IDs, right? You know, you know things. You know what data to purge or not. So usually this exercise, you have to do it. You have to purge the data before sale starts.
The related, when he says data is not removed from system, it's basically you have some historical, right? This many users came in and this many users went out. Those will stay. That log entries and all we don't remove.
Not about, but it's more about when you like it's simple, right? You place an order. Users are there. There is a transaction ID associated, right? So this is pretty simple construct. You want to trace a user from the time he or she enters until he or she exits. Exits means that the user journey when order is placed. So it is pretty much traceable. We know the system. DB team will understands it. So it is a collaborative exercise which everyone does it. Unless it is impacting anything, we don't remove. But over the period, these data has to be purged. There is no alternative. And we are talking millions of. Yeah, it is not. We cannot generate this type of load with 100. It could be millions, right? Huge data, no doubt. Yeah. It all depends. Systems are usually database systems you cannot scale out, right? On the fly. You have to keep buffer and good amount of buffer. We keep it sometime and then we pass it.
Usually before our sale.
Yeah, it is simple, right? Everyone is monitoring their systems. So there are KPIs for database systems also. So data DB team understand when they have to work on these things and they do it. Yeah, any question? Yeah. Sorry, I did not. Okay. So this is the performance testing we are telling, right? So basically we basically hitting with large number of users and just checking whether the system is the metrics are proper, like whether the key metrics like response time or rate is same. So this data science pipeline I did not get actually.
Yeah, mostly the data science consume data from
It is
Google Analytics kind of platforms.
so we so
Let me take this thing. So I think we are merging two things here. So for these systems, right, if there is a product coming from data science team also, let's say they build a service which is giving personalization, right? It's a service end of the day. So this system is focused on identifying the benchmarks which is asked by the particular team, have that benchmark and test it and give the feedback back to them. So it doesn't matter. It's a data science product or product from a team called storefront or team which is manages things at supply chain side of things. So what that is end of the day is a service. We call about black box.
yeah.
So I have another question. You mentioned you are using 100 users, right, to test your. Hello.
Yeah.
Okay. So you mentioned you are using like 100 users to generate the load comparable to your the peak traffic, right?
Yeah.
Can you please dig more deep on that? And second question is, as you mentioned, how do you do it? How do you perf this? Like building a separate perf system
So
altogether.
that's what we want to come on that one. But let answer this thing, right?
Okay.
To clarify the previous discussion, right? Srini mentioned that systems are usually on higher side because none of the system is built to take burst, right? Burst comes, there's a time when traffic increases suddenly, like morning or night time, right? There are people who are browsing, there are people who are placing orders. Night time, lot of people places order. You may surprise fashion industry, but still people are purchasing at 2 a.m. Right? So
I do that.
yeah, I assume. Yeah. So to that buffer has to be kept. You cannot run it like there may be very fancy topics you might have heard of, read of, that your scale is matching with the demand very frequently. That doesn't work in this industry. So that is the answer. You keep the buffer, and what you are expecting that load could be. For example, one sale is about to start, or every weekend you might have seen on our website some sale is going on, right? And so this is a known thing. We always expect some traffic to come. To benchmark the traffic, when you know the expectations, just the load and test it. How to do it? Let's say is very logical. On an average, you know what is your load. Let's say every time 100 RPM is there on your systems, and you are expecting 150 during that time. And if you want to do load testing at the same time, let's say there is no bandwidth available, every engineer is busy, and they found the same time to do the load testing, the peak time. You know the 100 requests are already there in the system. So question is that how much load you will generate from the system? 100 or 50 to 100? 50 only.
Okay, another question is how you are making sure there is no data inconsistency inside the system. Like, is it worth saving the cost
The
of having?
consistencies part are taken care by the systems. System, whosoever it is going to hit, the designer of the systems are taking care of those things. So if there is an inconsistency come, then the system which is coming in between somewhere is having a challenge. And this is one of the purpose of this system to surface such issues. So let me be clear, this system generates a and whatever bugs and things are surfaced. A lot of bugs surface after the system hits the system, our Myntra platform, multiple APIs. So to surface those things is the you can think this is the one of the objective of the system as well.
I have one question is how does your testing platform scales? So depending to generate the load.
We have it in the next slide. Okay, so these are the testing tools which was used before scaling. So one was My'23. So it was actually a Go-based load testing framework. So basically, people used to write the Go scripts. It was basically mainly used for horizontal load test. That is the which simulates the user pattern, user behavior during the sale. So people used to create the plans and write the Go scripts. They had to manually log into the boxes. They had to procure the VMs, and then they had to execute it with the whatever command line parameters, with the what is the load they are expecting, what is the duration they need to run. So all these things they had to mention. So second is a loader. So this was majorly used for vertical load test. So it's actually an open source tool. So this is also based on Java. So people had to set up this whichever team is using. They had to set up this tool in the virtual machine. Then they had to write their scripts in another repo. They had to create a jar out of it. You push it into the VM and then run with all the command line parameters. So this was one more challenge. So Jmeter, I think many people know, like it's a open source software design to perform the performance. So it is basically here you have to create the JMX files, and you had to either use the Jmeter UI to run, or you have the command line option. But again, you have to set up all these installations in the VMs and all. So otherwise, it is the Java jar, normally Java standalone runner class, where you run the normal Java application. So the challenges for these were one was the manual executions of the scripts. So every time you had to manually log into the boxes and then execute these scripts and you need to remember like what are the parameters you are going to execute, and you need to do all the installations for all the VMs. So these were one of the challenge. Second was auto scaling is not possible. So in case if you are asked to provide more load and your system is not scaled up to that, so you need to do the again the procurement of VMs and do all the setups, and then do the execution. Then there is no history of reports because whenever it is run from the single VM, you have to either push the reports to some central repo, or you have to take a copy or something, and then you have to even for sharing of the reports it was difficult. So fourth is no centralized location for load test execution. Because it is every team will be raising their own VMs and getting their own VMs and doing setting up their load testing frameworks there. So it's actually a cost obligation, because it is not, the VMs are not shared between multiple teams, which could have been shared. So, and there is no consistency in reports, because every team is using a different framework to run. So whenever, from a leadership point, if somebody has checking the performance of one system, one team with the other team, actually there is, even though the metrics will be same, but the reports are in different format because of different tool they are using. So to overcome this, actually we had built this Scale-it. So it's actually a cloud-based platform. So it's created in-house, and one of a few advantages are it's one low test execution. So it's like user can just tell the simulate, go to the Scale-it UI, go specify the simulation classes which you want to run, and the concurrency, and the till what duration you have to run. And post that, actually within a click of a button, it will be, the execution will be started. Then another is ability to scale. So since it's based on Kubernetes, so it can handle the increase in the load demands. So then real-time execution metrics. So we have option in Scale-it to pump the real-time metrics so that when the user runs on during the runtime itself, you can see the metrics of what is the how much load each API or each scenario here is provided, and what is the response times, what is the error percentage. So all these things he can see in the real time while he is doing the load test. So another thing is dynamic creation of test scripts. So here actually the user can actually provide Postman collection for basically for the REST APIs. User can provide the Postman collection wherein the system itself will design the simulation script. Then next is the centralized self-hosted reports. So the reports are actually pushed to a centralized location from where the user can see and he can share with multiple team members, or anybody using Skillet will be able to see based on the whether he's of the same team or other team. So next is the test logs. So he can there is an option, there is a log UI for the logs where he can see the live logs, as well as he can see what request or responses got. He can do add the printlns to do the debugging. Then there is an option to about the ongoing execution. So if the run is not according to the expectation, he can abort at any point. Then scheduled runs. He can schedule the runs by the scheduler feature and he can run at any time. And finally, the CI/CD support. We have exposed the endpoints so that the CI/CD team can use that to start the test run whenever a build is succeeded. So this is the Skillet UI. So here you can see the runs which has been done, and when you click on the detail section, you can see all the reports, all the logs, all the live execution metrics. The rerun section will allow you to rerun the same run, and the option is to schedule the run. This is the form the user has to fill while submitting the job. Basically, it is the test name, the duration, the concurrency is the number of users he need to generate from a single node, and the replicas is the number of nodes he can select. And the simulation is the class he has written to run the job. So these are the bare minimum mandatory fields you need to fill, and after that you can submit the job. Any questions here? Yeah, challenges part I'll talk in the next slides. Yeah. So this is how the report will look like. So basically we use a Gatling for our load test. So that is our load testing tool. So I'll explain in little detail in the next slide. So this is how a Gatling report looks like, and you can see the first indicator section where you can see the total load, and the green section shows how many is passed, and since there is no red section, actually it is almost 100% passed test case. So the statistics part where we have whitened the part is the API's names. So for every API you can specify a name so that you can tell like this API is how much percentage is succeeded and how much has failed. And the response times and all you can see in the other columns. So basically from this you can understand whether your service is working according to the expected response times and other metrics you can check from here. So here you can see the number of requests you have pumped and the number of responses you have got. So here you can see the load on the service. So basically here it's a ramp up and a constant user for some time. So here you can see like how much load you have generated from that is the number of requests per second, and in the number of responses part you can see how much responses you got and what is the load you had received. Yeah. Yeah. Yeah, I'll explain the design part. So this is basically the Skillet design. So in the front end, actually, we basically use the React server, so React.js. So basically, once the user fills the form, the React will send this request to the Node server. The node server actually, we have an Express, we are using a merge stack. So the React Express JS will send this details to the MongoDB through APIs, and it will it will call the controller section. So the controller section, we are using Golang. So the controller part, actually the use of the controller section is to run the Kubernetes job. So basically, for our load test, we basically use Gatling. So Gatling is actually a load testing tool which it doesn't have a GUI. You have to entirely write the code. So it is based on multiple languages like Scala, Java, and Kotlin. So basically, in Myntra, we use a repository which is shared among other people. So whoever want to do the VLTs or HLTs, so they will write the simulation script and they will push it into the repo. So whenever the request and the simulation class file which you want to run, he will mention the UI. So whenever he want to run it, actually the controller will download this repository and it will build the repository and it will create a jar out of it. So basically how you run a Gatling is, you need to have Gatling will run in a JVM. So you need to have a Java installed. So it's basically like running a Java jar command with the command line parameters for mentioning the concurrency and the duration. So the controller will download this repository and build a jar which will get uploaded to a centralized location, which is the blob storage which I mentioned there. So one more job of the controller is to create the Kubernetes job. So the Kubernetes controller will send the YAML file to Taurus. So we are actually not running Gatling, but we are running a Taurus image. So anybody want to tell why we are using Taurus or any idea of Taurus here? Okay, so actually Taurus is actually a wrapper over load testing tools like Gatling or JMeter or Robot. So it's kind of a wrapper in which, based on the input to the Taurus, it can understand actually what it has to run, whether it has to run a Gatling load test or a JMeter or anything else. So the use of the Taurus is in case if you are seeing your Gatling is not getting scaled up. So in the future you can go to JMeter by just changing the input params. So you just need to change the scripts, or you just need to change the way in which your simulation is created. So that you need not change the other parts. So that is the use of Taurus. So what the controller does, it will create the container which will run the Taurus image. So this Taurus image, it will get this YAML content from the node. It will get the YAML content and it will run the simulation. It will download the jar file from the Azure blob and it will run this jar with the command line params which is provided from the UI. So that is how the load test has happened. And the one more container the controller will create is of log shipper. So what is the use of log shipper is to provide the real-time execution metrics. So whenever you are running, actually whatever logs, the response times or P99, P95 or P50, all these metrics, actually from the Taurus it is sent to the InfluxDB. So from which the Grafana will be reading and it will be displayed in the UI. So this is how the live metrics is shown. So yeah, so this is the basic architecture of Skillet. So anybody has any doubts or here?
You got your question right for the answer for the.
Have you tried Locust also?
No, we did not try Locust. Yeah. Yeah, so Redis is actually a data store which holds the input data for the load test. So basically, this is mainly used for the horizontal load test. So we keep the input data in Redis because it is in-memory database. It fetches easy. So that is the use of Redis. It is not, yes. So yeah, the tech stack used is basically we use the MERN stack architecture. So where Mongo, React, Node, and Express is used for the front end and back end. Golang actually we use it for the controller. Docker and Kubernetes for auto scaling. Influx and Prometheus. It's for real-time metrics. Redis is for the input data store. And Taurus and Gatling is for the load testing tool. So, few of the challenges we observed is firstly is to identify and tuning the resource limits of Kubernetes. So basically for HLT or horizontal load test, we had to use the maximum resources of the or the maximum cores available for the from the machine because HLT we use a different setup so that no VLT pods will go into the HLT setup. So basically it is an exclusive setup for horizontal load test so that the entire whatever cores are available it has to be provided for the Kubernetes. So that resource limit we had to set, and for VLTs actually it is a different setup because multiple people are using for certifying their services. So it is like they had to accommodate maximum number of pods in a particular node. So we had to have multiple runs and benchmarking we had to do, and finally identify the resource limit for both. Second is the DP latency. So this is during the load test we understood after a certain point actually even after increasing the concurrency or the replicas the load generated was not increasing beyond a point. So we had plotted the metrics for the Kubernetes and the Redis as well as Gatling, but we could not find anything from the Kubernetes CPU or memory usage, or from the Gatling side we could not see any errors coming. So then we checked we started to analyze the Redis latency parts from the client side when the Redis is doing the operation. So we found an issue where the Redis is not able to scale because the latencies on the Redis was quite high. So this we had, tried to increase the cluster size of the Redis, and that's how we were able to solve this particular challenge. And one more issue was even after increasing that, certain APIs or certain endpoints were having higher latencies. So this we checked and we could understand that the certain Redis operation which is doing the fetch for the input data is causing this. So how we did is actually we changed this operation in such a way that it will be read once only and it will be stored into a Scala cache. So which will be used in the for the other scenarios. So that the Redis fetch will be dead only once, and remaining time it will be used from the in-memory map. So that was one more challenge. Then fine-tuning the thread count and memory each Kubernetes pod can support. So this is also like we had to do multiple benchmarking runs to understand what is the concurrency which a pod can support, and to find out the maximum CPU it is able to use it with that particular concurrency we are providing. So then it is the reports segregated across pods. There are each Gatling is run in different pods. So the thing is like we had to aggregate the reports and to show a single report where so each pod will be generating a Gatling report. It will have the load generated by that particular pod. So to create an aggregate report, we had to upload these reports to a centralized location, and finally one of the pod will download, and it had to run a combined Gatling script which will combine the reports. So this was one of the other challenge also. So there was a significant cost changes actually we saw when we moved from we were first earlier using VMs and when we moved to Kubernetes. So explain in the next slide. So initially, when we are using the Kubernetes, we are using the VMs across the DCs. So we were using multiple DCs at the early stages. So this was resulting in a significant cost. So then we checked what all can affect the cost, and we found actually by moving from multiple DCs to a single DC and to an affordable DC. So first since we had multiple DC, we first checked which is the affordable DC, and we moved all the clusters we convert all the clusters to single cluster into the single DC. Then we had manually needed to switch off and switch on all the VMs between the runs, and only the VMs which are required for the HLT run we started to on. So basically by manually turning off and on the VMs according to the need, we try to reduce the cost. Then we even check the Azure container instance. So Azure will provide on-demand containers. So these actually we also explore this, but what challenge we had is it was available. One thing is it was available only in Central India. Then they had a system like it will provide this much container for this much minutes. So in our case, actually, this was not suited because during the sale time when the load tests are higher, so the requirement for the containers will be more. So this kind of concept was not suitable for us. Even the resource limit and was provided was for 4 cores and 16 GB per container group. So they did not have any other resource limits. So which was not according to the limits we had set for our Kubernetes. So these were the challenges for Azure Kubernetes container instance. Then we had moved to AKS scale down deallocate mode. So Azure Kubernetes system actually in the scale down mode there is an option like deallocate where where the container gets charged only when it is in the ready state or in the use state. So in the deallocate mode, there are two modes. One is the delete mode as well as deallocate mode. In the delete mode, actually the container will get deleted if you are not using. So, but the ramp up time to start the container is more. So, but in the deallocate mode, the container will go to a not ready state so that the images and all will be automatically there. Whenever you start, the startup time will be less actually. So here actually we also observed a very high cost optimization because the containers are used only when it is required and it is shut down otherwise. And the cost got reduced by almost 85%. And here since it is used by Azure, so we have on-demand support. And there is a operational overhead also because earlier when we were using VMs, we had to do all the setups for all the VMs. We had to set up our own Kubernetes cluster. We had to create our own Redis's inside the Kubernetes for the input feeding, and these setups were we could go away. We could do away with these setups by going ahead with the AKS Azure Kubernetes system. So yeah, so this is the yeah. So this is all about scale it. You can yeah. Any questions or anything? Yeah. Flight recorder. No. So we did not. We were basically checking from the logs whether there are any errors. So we observed an out of memory exceptions. So whenever with the increase in the load, since it's run on a JVM, actually it has a default memory allocated by the Gatling. Yeah, so that so the only change we did was on the heap space, which we increased.
This was for the load test.
Yes, this was.
But what was on the application side? Do you use something like a JFR or something, or do you have an APM integration with the app so that you can see the metrics somewhere else later on when you do the load test?
So for application side, mostly for HLTs where entire engineering is sitting and checking issues. So they have different tools for observability side. APM integration is one of the widely used for finding such issues and outliers in the service and the performance as well as bugs also. Yeah. So it is the API integration is important because it is for them it is a black box, right? Yeah. They understand the user.
HLT is your basically black box, and whatever is the VLT is basically the
Yeah.
white box testing within the team.
White box, black box, sort of perception based here, right? So we build a platform. We provide it to engineering teams to knit their journey, which particular path.
Anybody with a Postman collection can integrate here and then start running the test.
Absolutely. Yeah. But based on how the systems are performing under test, and that feedback goes back to scale it and scale it, modify it. That is not there. That's why I'm saying they're saying it's black box.
Your agenda is finally at a point to give the auto scaling thresholds so that the application would be optimally run on the cloud, like cost saving and also like the whatever the spikes handling.
Out like we are ready for the spike.
Okay.
So,
Thank you.
What it sees is what it will have, but what each thing they'll have their own. It will not be into a single thing. It's like you doing.
It is not a very closed system which you are thinking
It's not
of.
a closed.
Very difficult to manage or build something like that. But yeah.
Like you have 24/7, right? Where you just do a ping and you just get a response time. You don't know what the Apache log on there.
Hello. While we are talking about the HLT specifically, now we are taking care of the entire journey, entire user journey, from homepage to PDP to maybe cart, maybe checkout. During this flow, you need different kind of data to be supported, because some products might be feasible, some products might be viable, at the same time some people may be applied. So during this entire journey, all the data mapping, does this platform take care of the generation of the data, or do we previously generate the data to support the journey?
Good question. In fact, you want to take it up?
Yeah, so the data generation, basically you are telling like whenever a person goes from list page to product page and add a product to cart. So this part you are telling, right? So yeah, this is on the fly, it is created. So basically we create a kind of plan in which actually we'll just feed the input which style it has to add to cart. But after that, actually everything is, and basically we create a test dummy user. So the dummy user will be already having some address or address associated with it. So with the input is just your style ID. So from the style ID, it will go till the orders. So that is how it will go. So that is the, we have to provide the input, but this happens during the load test only.
So whatever intermediate data is generated, they have been taken care of. For example, once you place an order, you have to send the order also, right? It should reach the particular pin code. So that's what the data has to be there. So all the system understands is a cascading one. What you're talking about.
Got it. I was just
So this system take care of it. Only thing is that it's a platform, little bit generic. So while people create their scripts, they need to take care of that part. That is one aspect. Second is to initiate the thing, right? So Redis he talked about. That is input data.
But don't you think it takes too much time? I mean, how do you handle this? Because generating the data on the fly and so much data you need.
It is some data you need before you start test also. So same set of API, different set of APIs you got to use to generate the data. You have to get it ready. It mostly required not for placement. It is required when you want to deliver the orders. Right. So yes, you have to generate the data before you can start the test. So it.
Yes.
One question may be that it is very contextual, right? It is not about scaling system infinitely. Everyone agrees, right? No one wants to scale. It's a cost. Directly cost and not only the cost, hosting cost, the people cost also. Uh,
So, so yeah, so those are actually fed from the, for example, a payments team is there. So they will be having knowing like what all types of features they have to test during the load test. For example, they want to test wallets, they want to test cards, they want to test CODs. So they will those are the datas that will be preloaded actually. So those accordingly this script will take it from the feeder file. So like for example, it will be random, but it will be a random. Yeah, we use the, yes, correct. Yeah, we use a test PG for this same payment gateway. Yeah.
Yeah, so this is the answer. You need to simulate some of the APIs. Yeah. So mocking platform, mocking libraries is the way to go, especially for the VLTs. For HLTs, when you are actually placing order in production systems, right? You can't do payment gateway testing. It is only cash on delivery. You can't do it because none of the payment gateway provide users or anything to support load testing. No one will provide. They'll provide users only for your functionality test, but no one will provide that one. OTP is totally in our hand. Hmm. Not OTP. We are talking about cash on delivery, COD. Hmm. So COD is the part which we can test, right? Hmm. So it will actually testify your so COD usually are some definitely good percentage of entire order placement. It tells you the system are scalable and working fine. Regarding payment gateways, you need to work with the partners. Hey, this is the time sale is going to start. Be ready, scale your systems. And you have to do with all the partners. Whether your partners which are giving you inventory, partners which are giving discounts, uploading, and there's a lot of stuff, right? So, in fact, your uh, cloud provider also, your CDN provider as well, you got to work with them so that they are also systems they are scaled up, right? We use Akamai. So if Akamai is not aware this amount of traffic gonna come, definitely is impact. So they also have to scale, increase the bandwidth at their end and other things. So it's a huge exercise running a single sale itself. In real scenarios, e-commerce is a predictive scenario, always. Yeah. E-commerce is not like it's unpredictable. Somehow people get crazy and start purchasing things, right? It won't happen. So it will be always, so we know. So usually when the load increases, right? When you send a notification, you get a pop-up on your, you're definitely going to click. Some deep URL will take you somewhere in the app. It will increase the load immediately. When sale starts in Myntra, EORS, right, which have going to happen June, July time frame. Yeah, we'll start campaigning. You know, you're aware of it. Yeah. Yeah, so it is lunchtime. So we can take more questions in lunchtime and it's ready and served on 6th floor. So what is the mode of then coupon thing or we can go directly there? Huh? Tokens are there. Okay. Oh, there itself. So we'll go to 6th floor. So 1 4 hour. So we'll have lunch over there. Thank you.
Yeah.
Hello. Hello. Speak here, Davish. Devanshu will say the same word. Peanuts. Supposed to be here. Yeah, it's supposed to. But hello. You're able to hear? Hello. Yeah, yeah. Yeah. I put it. Huh? Stop. Hello. Are you able to hear?
It is clear, right? Okay. Is it better now? Are you able to hear now? Okay, fine. I present it from here or Google? No, I'll present it from here, but because I need the presenter view. But how do I share that? Is that via Google Hangout or is there? Okay. Okay. Oh, it's not via this projector. Okay, sure. Yeah, sure. I didn't have those details. No, I don't have. It's a site Wi-Fi guest, right? This is the one, right? Really?
But once you have the internet, you will get the link.
Okay.
That is there on your अपने जो मीटअप वाला लिंक दिखा
Okay, I have to check that.
अरे वो वाईफाई
My Wi-Fi guest. Yeah, that's the username.
नहीं वाईफाई गेस्ट
Join to my Wi-Fi guest. Change it.
once you have the internet, after that you will be having the access to the
Mail. I think I should have access, but I don't know what the link is. I mean, in
So what you
LSP.
have to do is you have to connect the same Google Meet, right? You will join the meeting and do the share.
Yeah, that's fine, but I don't know what the Meet link is.
Meet link.
I can. Let me note it down here so that you know.
KKW. Where are you typing?
Then
CWX.
yeah, it's working. Right there.
Wake up call, wake up call, wake up call. Post lunch, right? Don't douche. And once again, the backbenchers request you to come the front to make the photographs later on. For your later kids, you will see that we used to have LSP meetups and stuff. So they will find that all our backbenchers do not be good. Super. So we are all set to start the second half. I think most of us are back, mostly settling down. Some glitches on the presentation part. So So Yahoo's Hadoop at one point in time used to be one of the largest Hadoop clusters of the world. I'm not very sure if it is still that because not sure of the size right now and what are the largest Hadoop clusters across the globe. But the team remains more or less the same, which manages Yahoo's Hadoop, and this talk is I mean, there are very rudimentary questions from very, very early days. Why still Hadoop needs Kerberos to authenticate? So I think he has some updates on that, how they are trying to do something better there. And that's an interesting talk because even if you go to cloud and you are on Hadoop, there should be some Kerberos there. So this is very interesting to know how they changed. Okay.
This mic is not required. Okay. Hi everyone. I think we had some issues with regards to connectivity, which usually happens with large-scale production engineering, and we had to fix that. But now we are up and running. So yeah, so let's start. So this is me. If you see any change in my facial recognition, that's because that picture is 10 years old, so I liked it, so I put it. Yeah, so yeah, I work with Yahoo. I work for the Hadoop Grid production engineering team, so we usually call Hadoop as Grid, and we use those words like interchangeably. So yeah, so we manage Hadoop, HBase, a lot of big data related infrastructure at Yahoo. So today, what I'm going to talk is about what is the authentication methods that are available for Hadoop, and what are the problems with Kerberos, and how security's landscape changed over the years, and what we are currently doing to address most of these concerns. And yeah, I have a few, I don't have a demo, but I have configuration and examples in kind of shared as slides as well, in the same slides. So yeah, so Hadoop uses Kerberos for authentication. It's a network authentication protocol which is used mostly in distributed networks, and it is the backbone for the whole 65,000. We are still the biggest Hadoop clusters in the world. We have around 65,000 nodes, around 30 odd clusters. We are now going to kind of be present in AWS and AWS and Google Cloud as well.
We need try to explain what node means, because this is a crowd with cloud era.
Okay.
So they may think this as VMs.
So a node is usually a physical, in a traditional parlance, a node is a physical instance, a bare metal box. Because nobody can. Usually the initial arguments were that nobody can beat bare metal performance, especially when you deal with I/O. But virtualization and cloud computing changed things. They made things simpler. But still, node is a physical unit of infrastructure. So when I say 65,000 nodes, it means that we have 65,000 physical hardware boxes in 3 different data centers present. And as I said, the backbone authentication system for Hadoop is Kerberos. So anybody wants to do anything with Hadoop, they want to submit a job, they want to talk to query, they want to query HDFS, they want to do anything, they need to first authenticate with Kerberos. So it is the authentication protocol, it is the backbone, it is the underlying infrastructure that is required. Anything that happens to Kerberos or the underlying central infrastructure can bring these grids to a grounding halt. Because we are so we use network time protocol to maintain time consistency, because Kerberos requires that. And if something happens, if there is a time delay or if Kerberos has issues, then the Hadoop components themselves can't communicate amongst each other for security reasons. So if I'm a real user is like you, me, physical person who has a life. And a headless user is a user which is used to run jobs, pipelines in an automated fashion. So every user, anything that needs to be done essentially from a security standpoint has to be done as either as a real user or a headless user, so that that job has identity, the logging mechanism, so we can trace back
for audit purposes, what is required. So the real users were using passwords. So I authenticate to the Kerberos, I punch in my password, then I get my Kerberos ticket. Headless users, because they can't punch in passwords because it is an automated system, they use something called as a key tab, which we'll explain later. It's not just users, it is the Hadoop services also, so any service that needs to present itself, I'm a client, I need to talk to the Hadoop service. I call that service as a Kerberos service. I mean, any service that authenticates using Kerberos, who is kind of providing the server mechanism, is a Kerberos service. They also need key tabs, but they are called service principals, and usually users are called user principals in Kerberos parlance. So once I get, so in Kerberos usually there are two types of authentication, initial authentication and then the subsequent authentication mechanisms. So the initial authentication is like, a ticket. Think of it like, once you come to the Myntra office, you're at the reception, you get your initial ticket. Then for you to access all the other rooms or, to go somewhere else, you need additional access. So that is called subsequent authentication. So if you kind of want to compare. So I get my TGT after successfully authenticating with Kerberos, then I request for a service ticket to talk to the end service, and that's how I authenticate. After successfully authenticate, I can query HDFS, launch yarn jobs, etc. As I said, a headless user uses a key tab, also called as key table, where the symmetric keys that are used for encryption in the Kerberos auth, which are used for encrypting the ticket and then the user decrypts it, are actually stored in a file called key table. So it's not really a text file, but a file which you can't catch the contents, but it contains your long-term keys which are used. These keys can be generated randomly or can be derived from your password based on the type of authentication. So if you do a K list, that's how you read a key tab file, like how you use VI for reading a text file. It'll have your principal name and the key version number, which was used to authenticate, the encryption algorithm that is being used, and then the actual key. So the key is the one-way hash. It's not so you can't derive the password from the back. So it is stored as a file. You use your regular Unix file permissions to store and to preserve your key tab. So think of key tab as your access card. If you kind of lost it, somebody picks it up, they can impersonate as you. So if I have access to your key tab, I can impersonate you. Then the reason why we give key tabs is because it won't ask for a password. It is for automated systems. And one thing about key tabs is only one instance of that key tab can be active at any point of time. So if I want to generate a newer version of that key tab which has a newer key version number, then the old key tab gets invalidated immediately. You can't use it. The tickets that were derived using that old key tab will also get invalidated because they were generated using the old KV. So that can't be decrypted. So what is the problem that we usually have with passwords? Yeah, mostly with Kerberos, and also these dictionary attacks and all were like, mostly Kerberos was designed in 1989, right? It is like, at that point of time, I was just 4 years old. And so that from then on, it is still the network authentication protocol actively used for distributed systems. Windows, Microsoft heavily uses it, and so these dictionary attacks, etc., have been like the causes of concerns over the years. Although the newer versions of Kerberos, etc., don't these are very difficult to emulate in production scenarios. But as a production engineer or SRE, your responsibility is to thwart all these types of attacks or possibilities, right? So if I choose common words that are available in the dictionary, an online or an offline attacker can try to derive from my password, or he can although I mean the current encryption algorithms are so strong that you would need a lot of computational power to do it, but these are still possible, and impersonation can still be done, and I can be some other user. There are various kinds of attacks that I can do if I know your password. I can do replay attacks, I can do a man in the middle. I can do, there's something called as a Xanaroti attack. Various different attacks are possible. So similarly, with key tabs, as I said, it's end of the day a file that is stored on the file system. So the permissions are very critical. So if somebody has a 777 on that key tab file, then that's it, you're gone. So similarly, as I said earlier, there can be only one version of the key tab that is active at any point of time. So if I have to rotate a key tab, old keys get rotated. So I just need to be careful because I don't want to, bring a production job down because, it kind of requested keys using that key tab that have a validity. If I invalidate that key tab, those keys get invalid and the jobs can suddenly kind of fail. And the onus is on, so Kerberos, when you kind of go, you kind of export the key tab. The onus is on, Kerberos doesn't have anything to do with how do we securely transport this key tab from the KDC. So KDC is the server, it's the key distribution center. You download the key, you have to securely copy it via SCP or any other careful protocol to the destination host from where the authentication will start. So the onus, there's no onus on, it's not Kerberos' problem, it's the end user and the SRE's problem. So over the years, right, we have been, following a policy of, trust always, verify once, and usually the traditional legacy mindset has been that network perimeter security, where I would have production network, I would have DMZ network, and then a corporate network. If I am a host in the production network, then by default I would have access to every other host or every other service, and the network firewalls are only giving us perimeter based security. And also the access is like, once I have gotten access, usually the access, there's nothing like, least privilege or, I can do anything. There is no role based authentication. I also don't have a lifetime or, on how much time I can be. There is no validity, like, I'll have lifetime validity to do a lot of things. So the modern concept from a security perspective is zero trust. Zero trust means that never trust. I mean, it's not really never trust, which, there should be some initial trust, which I have mentioned in the slides, but usually the slogan is never trust and always verify. So if a service wants to authenticate wants to connect to another service, wants to talk to another service, both the services should be authenticating against each other every time. It's not just for the first initiation connection, they would authenticate and after that they don't authenticate for eternity. So all the participants are mutually authenticated. So mutual TLS. So it's not just server side TLS, it is client side also does TLS. And every interaction is authorized. So if I want to kind of make a small change to a database or do an insert or an update, every interaction I kind of explicitly authorize it. And as I said, always verify, and then trust is not explicit, trust is implicit, time limited, and inherent. So it is not, so that is the zero trust principle. And for logging and audit and SOX compliance purposes, every action is logged so that you have an audit trail on what has happened. So adherence to zero trust policies, Yahoo has open sourced a very popular role-based authentication framework called Athens, which does certificate-based service authentication and role-based access control using fine-grained access control policies. So service identities are short-lived X509 certificates, PKI certificate infrastructure, where every user, client, workload, or anything, so a service can be a simple command, a job, a daemon, a server, a client, a user, gets an individual certificate which is unique to that particular principle. So here also we'll call them as principles, command or job or whatever. And once the client gets authenticated, the service will also additionally check for authorization using the RBAC policies that are defined in Athens. And so there are two kinds of certificates in Athens. One is the service certificate, which every user will have. And then the role-based, so if I want to access a resource, so resource is like a database object or anything, I would kind of create a role. All the members of that role will be the services, and the policies would kind of tell what I would do on that. And I would request explicitly now the role certificate using my service certificate. So it's not just I have a service certificate, I can go ahead. I will now request for an additional certificate using my service certificate, and then I would access the end resource. So Athens enables all the principles, or it follows all the zero trust core principles that were discussed in the last slide. And key to Athens is, it has been open sourced. Anybody can run Athens in their infrastructure. The underlying certificate infrastructure, which kind of does the certificate signing, issuing, and all, can be integrated with your own private PKI certificate infrastructure, or you can use third party. There are, everything is API controlled. So the underlying certificate infrastructure is key. Now coming back to Kerberos, as I said, usually it's key tabs or passwords, but Kerberos has something called as pre-authentication mechanisms to thwart all these security-related attacks. And one of the very popular security pre-authentication mechanism in Kerberos is X509 certificate based called PK init. So usually Kerberos, everything starts with K init because it is public key infrastructure. This is called PK init, so that's how the name came. And one would use, instead of passwords for my initial authentication, if I'm a real user, I would use a certificate and I would authenticate. This certificate is also issued using some kind of two-factor authentication, and it is short-lived. So I need to request this certificate. This certificate will have a limited validity. Similarly, if I'm a headless user, I would still use the certificate. I will no longer use the key tab file, and I would also request this short-lived certificate. The main advantage that PKInit offers is in the initial authentication, Kerberos key tabs were doing symmetric key encryption, because X509 PKI is usually asymmetric key because you have public key and private key. So that shared secret exchange between client and the initial authentication with Kerberos is now much more secure. So similar to Athens MTLS, with enabling PKInit in Kerberos, what we do is every service, every real or a headless user will be mapped to in Athens as a unique principal, and they will be, so they will have a unique identity both in Kerberos and Athens. And it is mutual TLS. So the Kerberos KDC will use a server-side X509 certificate, and the client, a real user, a headless user, I'll use a client-side X509 certificate. So the main advantage that we are getting is rotating this key tabs, maintaining these key tabs for headless users. So we had around 2,000 odd headless users, which were using key tabs, and we had to kind of be very careful on how they are maintaining their tabs. And then a strong two-factor authentication is established, so I'm no longer relying on just one password. And PKInit also it brings Kerberos, it kind of levels up Kerberos into this playing field of zero trust that, Kerberos is also now doing zero trust for authenticating in the whole grid infrastructure or zero trust based infrastructure. So by default, when PKInit was designed, usually Microsoft, a lot of these folks implemented this, or Sun implemented this using smart cards, which were just attached to your ID cards, and you would kind of put this smart card into your terminal box and you would authenticate. So these smart cards used to have your certificates, but you can use any certificate that you generate. It can be internal certificate, but the concern with PKInit is it relies on two additional attributes which are by default not part of your regular PK infrastructure. One is EKU. In the EKU, you would specify the PKInit. You would say that this certificate is specifically for using for PKInit, and then the ID PKInit is an attribute to associate that with the Kerberos domain. So if you have to generate certificates for PKInit, you need to generate those certificates using these two attributes. So usually people would use OpenSSL to request the CSRs and certificates. So an additional extensions file is used where you would mention these fields and request the certificates. The problem that we have with this regular certificates is largely popular vendors like DigiCert or Symantec or even internal vendors like Athens, etc., don't support this because it is an additional thing. They need to kind of add these modules, these extensions, and it kind of gets cumbersome. So when we spoke with DigiCert, they didn't have support to issue us PKNet-based certificates, and also we didn't want to use public certificates in the first place. So we'll kind of, I'll just explain how the certificate looks. So usually you would have been like, you would have seen these certificates, very popular fields in those, but as I said, the extended key usage kind of tells the one on the left hand side is the server side certificate, where you have an OID which says that, that it is a KDC right kind of certificate. And on the bottom, as I said, it is an additional extension field, so I need to use ASN parse to kind of get the additional details. And so that is where I'm mentioning my domain. So my domain or a realm is like a logical entity for, it's a logical grouping or an isolation, which says grid.example.com is where I will have all my servers of entities in it. Similarly, for the client side, I have this additional attribute called pknet client auth, and here the username for this example is svc1 headless. So the way a certificate is uniquely mapped or pinned to that user is using this additional field that you see here, svc1 headless. That's how I would know that I am svc1 headless principal and I would require a TJD for this user. Right. So as I said, it was not so viable to use these IDPKNet SAN based certificates because popular vendors would not support and you would require additional infrastructure. Kerberos in version 1.16 released something called PKNet Cert Match, where you could use any certificate that you have, and using the PKNet Cert Match feature, you can use that to authenticate. You can use any certificate, regular certificate, as a Kerberos PKNet certificate. So I have my Athens infrastructure, which is giving me the X5009 certificates. So using PKNet Cert Match, I can integrate those Athens X509 certificates into my Kerberos infrastructure and use it for PKNet Kerberos authentication. The same certificates, not just for Kerberos, can be used for any MTLS also in the service. So the advantage that we have with PKNet Cert Match is first we are able to integrate that with Athens PKI or any other popular PKI infrastructure. That's one very popular one in the Kubernetes world is PFI, Spire, etc. So, and these certificates are unique for every user and short-lived. And then the private keys never leave a user's laptop unless you explicitly move them, or a host or a node or a service. They are so using my private key, I would request for a CSR. That CSR is what goes to the PKI infrastructure and get the certificate back. So my private keys are never leaving the system, which was a major problem in the symmetric key encryption, because the key table is one that I have to securely copy from the KDC to the destination. Here, every host can, once it is securely bootstrapped, every host will have a unique private key and get a unique certificate, and they can authenticate. Similarly, every Kerberos KDC from a server side is also securely bootstrapped. So the secure bootstrapping is the initial establishment of trust, where every box gets its first pair of certificates, and then they are also short-lived. So we kind of renew the certificate frequently, and as just like a user, private keys never leave the system, and both the keys and the certificates are rotated frequently. So now, if I am using a regular certificate, so if you see the certificate is much straightforward, it's very simple. So I am relying on, so this is usually a very popular web server certificates, that's how it looks. So it can do both server and client auth. And I am relying on the SAN DNS name attribute here, which we usually do for server side web-based auth or web-based communication. So kdc.grid.example.com is my KDC. Similarly, on the client side, I would mention that to trust only certificate that matches this field. Similarly, now to uniquely identify a user, I'm using the certificate attribute canonical name CN, and I'm kind of minting the certificate saying user.username. If it is service, I will be calling it service dot, I mean, if it's a command or a job, it will be service dot that command or job name. Right, so if you were using key tabs, so the one on the top left is how I was using key tabs. That's a that stores my symmetric key. On the server side, you see the key that user has a key in his database. I'm using kinit by passing the key tab, and then I got the KGT. That's the initial ticket. Once I use pknet based auth, if you see on the right hand side, there are no longer we are no longer storing the symmetric keys in the Kerberos database. We are using a symmetric key first to establish the shared secret. So we are using, as I said, pknet set match allows me to use any regular certificate for Kerberos auth. So I kind of pinned. So using pknet set match, I said service one headless will present you a certificate whose CN name matches user.service1 headless. Similarly, so the user when he tries to knet, if you see, instead of passing the key tab, he's passing both the cert and key and authenticating. So there is no change in the actual ticket that you see. The ticket is the same. I think for the sake of time, we'll kind of just skip, but I'll just give you. So the only difference between pknet and the regular ticket-based, key tab-based authentication is the initial key exchange, where on the right-hand side, if you see, the user is now passing his certificate also, so that the Kerberos KDC can use that to sign the response that it gives. So I'll not go into the protocol details because that's very much theoretical. Right. So any questions so far? So nowadays, I'm not sure what, usually if you were using, let's say, Kubernetes within itself comes with a PKI certificate infrastructure within itself, where every pod, every container, every instance, every service will be given a certificate. Similarly, if you were using HashiCorp's products, HashiCorp also does a lot of this. They give you certificate-based authentication. They give you so the modern era is mostly certificate-based authentication. Every user or a principal, especially if you are in cloud, then it is very much required that you use certificate-based mutual TLS authentication, because you never want to trust it is not your territory any longer, right? It is AWS or GCP, where it's not just you. There are many other players who are being shared the same infrastructure, same network, etc. So network encryption at wire at rest are very critical. So Kerberos also is coming. Kerberos is like the big daddy of the symmetric key encryption. It used to exist in the traditional world of distributed network systems, etc. The modern infrastructure is moved from symmetric key to asymmetric key, but a lot of companies, etc., still use Kerberos for authentication. It is still very much tied. Like if you are using Red Hat Linux products, Red Hat, or if you are using Fedora also, there is something called free IPA, where Kerberos and LDAP are integrated into one single service and given, so that if you can, it is very easy and straightforward to use it. So yeah, that's what I have to, if you have to differentiate. Okay. Yes. It's called Windows Active Directory Domain Controller. Underlying protocol is Kerberos. Linux mostly uses MIT's Kerberos, MIT's implementation. So there are three major implementations. One is Windows Active Directory, Microsoft. Then MIT Kerberos, and then Macintosh and all, they use Heimdall. That is also popular Kerberos, but not as popular as MIT. you can very well use Kerberos also in cloud, but the modern infrastructure or the Web 2.0 or Web 3.0 infrastructure has moved from Kerberos to certificate based authentication. So everybody supports certificate based authentication in one form or other. So encryption over the wire, everybody uses X509 certificates only. So there is no mandate that you would use Kerberos unless your systems were built to were designed to use Kerberos, and that's when you can use it, and you can use features like X509 certificates and in Kerberos, and you can still use Kerberos in the modern authentication world. Yeah, correct. So OAuth, SAML, auth, all these are usually for real users, right? They can be extended for non-real, like headless users as well. Like what I just mentioned about Athens is it just doesn't do X509 certificates. It supports, so we used to call them N tokens and Z tokens, which are now called as access tokens, role tokens. Access tokens are they are very much they follow the open standards of using OAuth or what Okta everybody uses. It's the same access tokens that Athens also supports. So instead of X509 certificates, I would still require the certificate to get the OAuth token or a JWT token, and then use that for authentication.
So we thought of how do you rotate the certificates? Like if once the private key certificate is created, like what is the duration that you said?
Right. So just for this presentation to be very crisp, I excluded a lot of this. So we have agents running. So the whole Athens infrastructure is very big. So it comes with once the node is bootstrapped, it has every node or every user has an agent running, which will rotate. So we usually rotate it once once or twice a day. So within a day, these things get rotated, and if servers are actually, so in the good old days when certificates were rotated, servers have to be restarted, services have to be restarted, like Hadoop, like Apache web server or whatever. But all modern web servers or applications support something called as hot certificate reload, where one of the thread in the server will just reread the certificate and use the certificate. So every private key doesn't have a validity, but we rotate it. Every certificate is only valid for 24 hours.
Another question, in the MTLS, we understand that the client can verify the service principal of the service, but how does what mechanisms that you had to verify the client from the server side? Like, is it any host name or IP address or
Right.
things that you have included in the certificate?
So usually these things are called MTLS filters. Anybody can, for Java you can write your own MTLS filter where you can uniquely identify a client. Usually clients are identified using the CN, the canonical name, because client-side certificates won't have SAN-DNS names. They, unless you kind of mint the certificate both as server and client-side servers, both client and server auth. So in the case of Kerberos, it is using this pknet cert match, but every popular service provider, every popular RBAC solution has one way of uniquely pinning a certificate to a principal.
But in the common end, the field is like very small, and if you're running grid, there will be thousands of servers. So it's very difficult to just use the CN. Sometimes you need SAN as well, where you can store more information.
Yeah, sure. We can. It is for CN. So any attribute that we use for authentication, the attribute that is picked is a unique attribute. So I'll kind of cover some part of that later in the slides also. But we never pick attributes that are common across anything. So if you take the example of KDC, in the KDC we are not relying on CN attribute. Instead, we are relying on the SAN-DNS name.
Okay.
I am not sure about that, but yeah. So we use the same mechanism to redeploy the certificate. So once I establish the initial chain of trust, when I'm getting the certificate, I'll still use my existing certificate to do the MTLS auth with my certificate provider and get the new certificate.
Then we get the new certificate and the next time they...
Yes, I mean once the certificate is rotated, the old certificate is no longer used. So every authentication is MTLS, and as you said, so there should be some kind of anchor. So in the case of Azure Active or Windows KDC, the Active Directory is the anchor. That is the one who kind of is overseeing the whole. Similarly, if you are using a XYZ certificate-based infrastructure, Athens becomes the anchor. If you are using Kubernetes,
The Athens server is there inside your own.
yeah, yes.
And the root of trust root is anchored at Yahoo itself. I mean, Yahoo, you don't put the third party.
So for internal authentication, so the whole idea when you are establishing XYZ certificates within your perimeter is to never use third party certificates. You would only use public certificates for public facing entities. And within your infrastructure, you would only use a private CA, which is managed by one single central authority, which is secure.
Been there up to the expiry. So for initial deployment infrastructure cluster building, we done. Then we were handovering all those to the application owner or to that team. They were asking that question, how I will be managing those certificates now. So for them, the question was still they need to build another pipeline to do that, and how it is. So we were not able to get any solution out of clouds providers that can do that. So we were procuring certificate from Venafi, which is the enterprise grade solution.
Okay.
But how to renew, redeploy, and all that.
Okay. So yeah, so here also when we procure a certificate, if that certificate is valid for let's say 6 months, then we automatically renew the certificate on the 5th month itself. So if our certificate is valid for 90 days, then we automatically renew the certificate within 60 days, I mean at the 60th day, so we still have 30 days buffer, and then the client would fetch that certificate and it would renew it. So even though the certificate validity is 90 days, every time it's actually on principle you're realizing your cost only for 60 days, because we don't want to wait till the last day and then renew. We don't want to even throw the error of certificate has expired or you have to verify. Right. As I said, everything is based on initial chain of trust. So I would use it's very tricky. It's like a chicken and egg problem. But once I establish the bootstrapping process, I would use my Athens certificates. If I'm a public facing entity, I need commercial certificates on my host. I would there would be one service which will be deploying it in a central store, and then I would use that central store would require me to authenticate using Athens certificates. So I would use my Athens certificates to fetch those certificates. Right. So a quick difference between key tabs and certificates, symmetric key versus asymmetric key. You can mint as many as for the same user principle, you can mint as many user certificates as you want. Destroy in memory versus key tab, it's not possible. And then the onus is on the not on KDC but on the end user to safely copy the key tab from the KDC to the destination node, etc., which is not the case with X509 certificates. But that being said, key tabs are not completely going away. They are still required. They are still required because PKNet is just for initial authentication. Every other authentication, like the subsequent authentication, service authentication, etc., still requires a long-term key or a key tab. And Kerberos within itself does a lot of things for administrative purposes, replica, everything is based on key tab based authentication. So that being said, and every grid node still uses, because every service that uses key tabs to authenticate the client still requires a key tab. So that because we have 65,000 nodes, we still need 65,000 key tabs. But we still want to address this problem of zero trust with key tab management. So what we did was we built a service called key tabs for HTTP, where in the traditional world, historically what we were doing was we were generating key tabs, storing that in a centrally encrypted store, and securely copying it to every node that requires it. Versus what key tab or HTTP does is it's a RESTful web service API. It does mutual TLS authentication with the client. So anyway, every grid node has been successfully bootstrapped to Athens. So I have my X509 certificates. I would then request a KDC, key tab or HTTP. So Kerberos by default doesn't provide these services over HTTP. They have something called as KDC proxy, which is only for authentication but for not communicating the key tab securely. And also there is a Python implementation, PyPy kadmin, which doesn't really suit our requirements. So we built this Go-based service, which is a RESTful web service. And this is mostly used for securely copying the key tabs to every node on demand rather than storing them in a central store. So every client will automatically come up when it comes up. When I mean client here, it's the grid node. It can be any node. It can be a data node. It can be a name node or anything. It would talk to this API service and present its client certificate and then request for its key tab. So, and it can also do a CRUD operation, which is like create, update, delete. But for doing CRUD operations, we would require a higher level certificate because a simple service certificate can't be used to create or destroy principals. So the way the key tabs or HTTP service was also built is to adhere to the zero trust standards of how we are doing SCP. So when you usually do SCP or SSH to a box, if you would have your the SSH host fingerprint, you would punch in yes if it's a different fingerprint, and it is permanently adding it into your SSH known host file. You never verify it again. So that is a good example of not what zero trust shouldn't be. Like you should never trust your service. You should always when you type in SSH, you should always verify the server certificate. So instead of using SSH, using HTTP, MTLS auth, I'm always verifying the client that is requesting for the key tab, and I'm only giving that client its own key tab. I'm not giving any other key tab or any other principal to it. So we rely on Athens. Every node anyway has the X509 certificate, so it would go to this central to this key tab HTTP API and ask for its key tab. We uniquely identify that node using the SAN-DNS host name. Similarly, as said earlier, the private keys never leave the system, so it's just authentication using MTLS. For additional security, what we do is we do some kind of regex pattern matching on certificate attributes. We also do a reverse lookup on the client that made the request to verify the originating IP address. Does it match the host name? Then we check the SAN-DNS attribute fields in the certificate as well. Only if all of this match, we give its key tab to that client. If that client is behind a network load balancer, if that host is behind a network load balancer, and that network load balancer's key tab is also required for the service, then we query the network load balancer API to verify that that client is actually indeed a member or a real host of that network load balancer, and only if it's a member we give it its NLB key tab. If it's a CNAME, we verify the DNS CNAME, is it resolving to that host name, and then only we verify. If there is a proxy in between, in MTLS by default it's a proxy IP address that would show when the connection gets initiated. But there's something called the proxy protocol which many popular proxies support, where the proxy protocol header can contain the client IP address that initially connected to the proxy. So using proxy protocol, we can still get the client IP address that connected to the API service with a proxy in between, and we still do the validation. So these XFF headers won't be set in MTLS auth. So you can't rely on XFF headers. Proxy protocol is a binary protocol which are the initial bytes that are sent before the HTTP connection is initiated. So if I am a client, I connect to the proxy and I have to first enable the proxy to do proxy protocol, and my server also has to support the reading of proxy protocol, because my server in a HTTP protocol, as a HTTP protocol, it only understands HTTP. If it is seeing some random bytes, it kind of gets messed up. So what the proxy protocol does is, in the initial HTTP communication, the first bytes of proxy protocol V1 is text based, proxy protocol V2 is binary. The first few bytes is the proxy header, which is not to be confused with the HTTP header. HTTP header will still remain the same. The proxy header is something that is set by the proxy. And the very popular vendors like Go HTTP Server or every Nginx have the ability to decode this proxy protocol header and get the fields or attributes in the proxy header. And one of the concerns with XFF headers is I can mangle those headers. I can kind of set anything in the XFF and I can let the server assume that it's a valid client. So proxy protocol we do, because it is binary, it is not that easy. Right, so quite straightforward. So if I'm a server, so the example, every host is uniquely identified using its SAN DNS name. So test1 host has my test1, test2 host will have my test2, and if it needs to do CRUD operation, we use a role certificate because it's a higher order privilege. On the server side, the same things that we saw earlier, it's the same KDC, KDC proxy server side certificate. What we do is we map that service. So I'm a service, I need a key tab for service 1. My service identity certificate will be having the CNAME service 1 here. I have a simple KV map which would map that key to the Kerberos principles that are, so usually in Kerberos, anything that has a slash is a service principal. The one that doesn't have a slash is a user principal. So I would know if a service 1 is making the request, I need to give the service 1 all this, a single key tab that contains all these principles. If it is service 2, then it would be a different service requiring different key tabs, and it would give, the API service would recognize that and give it a different key tab. Right, last slide. So it's just an example. So by default, we have fetch key tab, which by default fetches the current version of the key tab. But the main advantage that we are also having with the key tab or HTTP API is key tabs by default don't have an expiry. They are symmetric keys. Using the API, the client is able to request the server to rotate its key tab on a periodic basis. So let's say whenever we want to do server upgrades or something like a 30-day period where we always want to mandatorily rotate a key tab, we don't need to worry about bringing the service down and restarting and worrying about the service going down. I would in my argument itself, I would request for rotate, and I would preserve my old keys, because the TGTs that were requested using the old symmetric keys should not get invalidated. So I would preserve my keys, but that would go on. If you kind of just keep on doing that for a 65,000 node infrastructure, you are kind of maintaining that many entries in the database size increases. So at one point of time where your service is went down for some hardware issue, or you're kind of completely destroying and rebuilding something, you can rotate the key tab but set preserve to false, so that all the old keys get purged and you only have the latest key and you can use that for authentication. So that is the end.
Yeah, so if you need a minute of break when this sets down, please get some water probably and coffee, whatever.
दोनों अपडेट और load balancing हो रही है
आशुतोष उसको तो देते हैं, साला जी आ रहा है, वो फंस जाएंगे फिर वो रितेश साला इम्पोर्टेंट फ्रीलांस करने से या वो नहीं कुछ दिन मूवी में था उसके बाद Yes, well, चलो you have to give wake up call, otherwise you will not say it. सचिन आप जगह लीजिए, सचिन आप जगह लीजिए, फिर माहौल बैठ जाएगा, आप बैठेंगे तो सारे लोग बैठ. Okay, so let's get back to our last but not the least talk, obviously. So Aditya is going to take us through the real-time analytics that Myntra uses to target you, to be precise. Okay, over to Aditya.
Am I audible? Prefer to walk around, but I need to move over the slides back and forth as well. Sure, sure. The only thing is I can
Speak outside.
no. I'll go on the spot. But the problem is this is the main diagram. The thing is every time I go forward, I have to go back.
Can we go back? Go if
Sure, definitely.
as long as it doesn't lock. We'll go in full present mode itself.
Yeah, one sec. It does lock, or at least temporarily I've disabled that.
So when you are presenting,
Yeah, cool.
then you have to share also.
Sure. So everything is in sequence. The only thing is once this slide comes.
Just tell me, go back.
Sure.
And join the.
I think join.
Come and see.
Hello. Okay, so request everyone to take your seat, please. So Aditya, all set? Over to you, Aditya. Please go ahead.
I am audible, right?
Hello? Yeah, this is fine? Yeah. So, hi everyone. My name is Aditya, and I lead the near real-time analytics platform Mintra, as well as the Airbus messaging platform. It's a platform which is used for all the async communications across the various systems. Currently, I'll be focusing only on the near real-time analytics platform, as in why we built this, what were the requirements, and what are some of the architecture of this platform, as well as the challenges, right? What are the various challenges in maintaining such a platform? So first question is why, right? Why do we even need a platform like this? And what is the purpose of this? So one of the things is that if you look at any platform like Myntra, right? You need real-time information about sales and campaign performance. For example, if you're showing ads, and if somebody is bidding for these ads, right? They were bid for a particular amount, and once that amount exceeds, you should immediately stop showing the ad. So all that has to happen in real time. As and when the ad expires, you should stop showing it. The second and the most important thing is personalization. So today everything is personalized to the users who are using the application. And the intent of the user changes often. Today you may be browsing for something, tomorrow you may be browsing for something else. So what that implies is, based on your intent in that session when you're browsing the app, the system should immediately know what you're dealing with. So this is a platform which deals with that, to understand the near real-time requirements of the user. And at last but not the least, this is a platform end of the day, right? We are not, so it should be in a way that anybody can come to the platform and build their respective use case. So the product teams of Myntra will deal with a lot of use cases. All the way from search, for example, or you're seeing various ads in the Myntra app. Or it can be as simple as the recommendations that you see. All these are different applications, different products, and anybody should be able to come and onboard into the platform. So this is why a platform like this is needed in the first place. So the thing is, before NRT was there, the challenge is typically you dealt with bad jobs. These jobs run maybe at a day's lag, which is still not bad, but given that now personalization is very important and the intent of the user is changing often, a day's lag is not enough. It should be immediate. As and when the user's intention change, the system should change according to that. So the next thing is, what are the requirements of such a platform? Because of the scale of the system, there are a lot of requirements. So one of the main things is the data processing volume and the data freshness. When I say volume, we are talking about, say, tens of millions of events coming every single minute. And this is just a fixed, again, what number I'm saying is, you do have normal days in Myntra, you also have sale days in Myntra, because it's an e-commerce company. What that means is every minute, the amount of data which is being processed is massive. And the system should be able to handle that. The second thing is data freshness. End of the day, this is a near real-time platform. Most important thing is the moment the user does an action in the app, how fast is it able to reflect. So the data freshness aspect is very important. The other aspect is, fine, you're doing all these analytics, but it has to sync somewhere. As in, let's say for example, you're searching for white t-shirts. Now the next time you open the app, it should show you white t-shirts. Or not next time, immediately, right? You move forward, you come back. So that means that whatever the system is processing, it should be immediately made available back to the app. It's like a full cycle, right? From the app we get the information, and the same information has to go back to the app. So that is the high serving throughput and low serving latency. Sitting right in front of the app, which means that it should be able to handle all the requests coming from the app, and the latency has to be sub-millisecond latencies. Again, I'll come to that, why that is the case. The next thing is quick development lifecycle. So considering, as I mentioned, there are multiple products who are building their own use cases, it's very important that you're able to develop and test these use cases very quickly in the platforms. And the other very big item, which is in fact the toughest item here, is the reliability and scalability. Because of the sheer scale of the volume, as well as the requirement of high throughput and low latency, it has to deal with a large amount of data, and the system should be up 24/7. Because all these are continuously running data and it really cannot go down. The question is, how do you manage a system of this scale? And finally, multi-tenancy, because we're not talking about just one job which is running. There are multiple use cases, and again, this is a generic platform. You can put any number of use cases in it, which implies all of them should be able to run without deteriorating a different use case in the same platform. So the next is the how of it, as in how the whole platform, what is the architecture of the platform, and what is each component of the platform. So this is the entire architecture. So I will take this in phases. So the way I would break this is, one is called the clickstream ingestion, which deals with, so any action you do in the app, for example, you log in, you go purchase something, whatever you're doing, that comes as something known as a clickstream event. That is a clickstream ingestion. At the same time, you have something called as Airbus of server ingestion. So there are a lot of things happening in the backend as well, in the applications. So that comes via the server side, the Airbus ingestion. Then you have this Quicksilver in between, which is our whole stream processing platform. So this does the heavy lifting of all the processing. And finally, once we do all the processing, you have to serve the data out. Again, serving of the data here can be to machine learning platforms or even other systems. So that is how I'll be breaking it. So first, coming to clickstream ingestion. So there are multiple things here, right? One is in Myntra, you would have, we have an application. Again, it runs in both Android and iOS. Also, there is a web application and there is MWeb as well. So all of that event has to flow into Myntra. As in, I'm talking about just the actions done by the user. So for this, what we do is we have a Golang service called Heimdall, which sits right in front of the app. When I say right in front, of course, there's a load balancer and all that in the front to protect the system. But I would talk just from the standpoint of the service. What this service does is it sits in front of the app and it acts as an interface layer. For every event coming in, it will go into this service, and from that service, we dump all of this data into Kafka. I think we can go back to the previous link. Yeah, so this is what I was mentioning. So all the events from the app come to Heimdall. From there, we dump into something known as the primary Kafka. So these two components are very, very important. The reason being, any problem here, then again, it's more like there will be no data entry into the system. So here, the purpose of Kafka is more like a buffer. Again, Myntra has a lot of notifications and there are surges in traffic. So this service sitting in the front will take in all the requests and route it to Kafka. Once it's in Kafka, we do a lot of processing on it. Here I'm focusing only on the real-time processing, but we also have a different arm, which I'm not mentioning here, where we take this data, we dump them into a data lake, and we do other sorts of batch processing on it. You can think of it like that, yes. It's just more like a router. It acts like the initial entry point, and it decides, okay, I should route it to this topic in Kafka. Yeah. The next thing is, apart from Clickstream, as I mentioned, we also have this Airbus or server ingestion. Again, Airbus itself is a big platform in Myntra. I don't want to go into depths of that. But what I can say is Airbus is more used for async communication across Myntra. Myntra again has a microservice architecture. All the services of Myntra communicate through this architecture. Now, in many situations, we may need some server-side events as well. Just not the events from the app are directly enough. So there, what we do is we can also integrate with these server-side events, and you can do other operations on that. Now, some constraints of this system is, again, Airbus is platformized, meaning anybody can onboard onto it with the help of an SDK. And also, this system has a metadata management along with it. So if there are 1,000 topics in Kafka, for example, all that metadata is centrally managed. So if we want to do any near real-time analytics, we know what the data is, as in what data is present where, and how we can contribute. So this covers the overall ingestion layer on how data is coming into the system. And next I will look into the processing layer. But is there any questions? No, they are very different. So, you could not. You could say that the only difference is Airbus is more a platform meant for only async communication. So what we have done in Airbus is there are other provisions like how clients can onboard to it. So every team in Myntra does not maintain their own Kafka, as in it's a central Kafka team and all systems onboard onto that. Whereas here, because of the sheer volume, it's a separate instance altogether. It is also Kafka only. Though I mentioned Kafka, it is Airbus, it's Kafka sitting behind the system. Again, the communications through an SDK. All the clients we provide an SDK in Airbus. All the clients can produce using that and consume using the same SDK. The SDK sits on the client. Kafka is just a central layer. Yeah.
So they have got these two Kafka systems. Have their
Yes. It doesn't have to be in sync. These are independent systems.
The topic names are different of the metadata, so one thing should have
That should
basically would create problems later on down the line.
Yeah, so got it. So what we have done is in Airbus there is a metadata manager. So we know exactly what's there in that. This system also has its own metadata manager. No, they don't. They don't have a single source of truth, but this platform has a single source of all the data coming into it. So now if I have to build, I'll come to that, right? In order to process jobs in this.
It is very simple. In one place you have something called a T-shirt and the other place you have something called T-shirts. Both essentially can be same.
No, here these are different altogether.
No, I'm just trying to talk about just keywords, certain keywords.
Okay.
You have something which is likely to be essentially the same. And we do not have ensure that they are the same. Later on down the line, we will have issues with the data later. That's not so. I'm just talking about that. I don't know. It's a really problem.
No, here it shouldn't be a problem because we don't allow these to interact because they are meant for very different purposes. And when we do connect both of them, we join them in these jobs. So these jobs have the logic which will connect them always. We are not unify would not be the right word. It's not like we have say one topic here, we just combine them. We don't do that. What we do is in these jobs, we can combine the data from different Kafka topics. Because if you're combining them, it cannot just be append, right? There'll be a business logic which is combining it. Yeah, this is Kafka as a service basically within Myntra. Yeah, you can. So some of the challenges with just this clickstream ingestion especially, right? One is scaling the system up and down. Because again, Heimdall is a stateless service, so it's not that difficult to scale up. But coming to Kafka, it is a challenge. The reason being it has data in it. So if I'm scaling it up, the only possible way in production without causing problems is you have to do a partition reassignment. Which is again not free of problems. When you do a partition reassignment in Kafka, the problem we have seen is the producer does not know that the rebalance is happening. Many times it can error out. So the only way out in this case is one, we have multiple retries in the producer, in this case which is Heimdall. And let's say all the retries exhaust and you're still not able to write. We just write it to a different topic which is not getting rebalanced. So again in Kafka when we say scale up, it's not just adding more brokers to it. It's mainly about scaling up the topic present within it. So the only way we came across this is that during the rebalance, if there is any problem, we write it to a different queue and then we replay it back to the main queue. That way there is no data loss. Coming to resiliency, the way we have set up Kafka is that we have a min in-sync replica of 2 and the replicas is 3. And again in the producer what we have done is minimum 2 replicas should get the data before you move forward. So what that implies is we can survive if one broker goes down and that's the current set. Coming to event routing, again as you rightly called out, it is more like a router. So what this Heimdall does is it decides that based on, there are multiple actions done by the user. We have too many events coming in. We categorize these events and route it to the responding topics so that you don't have to consume everything when you have to consume it. The next thing is the stream processing itself, right? So once, no, it's automatic, it will come in. There is no, whenever any new event is there, it will automatically come in. But we do have, we have a governance in place there, right? You cannot, so the way it works is when you're onboarding something, there's a production system end of the day. So if a new feature is going live, they tell us, okay, this is the new event we are onboarding. And there is a governance to ensure that, these events are validated before they come into production. Because if the wrong events come in, it can, again, this is the single source of entry for all analytics in Myntra. Any damage here will cause repercussions across the pipelines, including reporting and everything. Yes, we need to. But that is necessary. That governance has to be done.
So is that following on to that?
Mhm.
Do you have some sort of a configuration file to say that these are the events that you have?
Yes, we do. We do.
That's basically what makes it.
Yes, exactly. This is like a central config, and it is more like an agent which keeps pulling it. So we just need to change the config and the system will get it. So you don't need a service restart or anything. It will automatically work. Mhm. Yes, absolutely. Absolutely. Yes. Yep. So multiple aspects here, right? One of the things is in the app itself. When these events are fired, see, there is a probability that the service may become intermittent at that point, right? And considering this is the first entry point, in the app itself, there is a buffer which is kept, wherein if suppose the endpoint is not available for some reason, or there can be anything, some network issue, things which are out of our control altogether. So in the app, there is a limited amount of buffer, wherein if the service is not available, it keeps buffering it in the app, both Android and iOS. Of course, there is a size to the buffer. You cannot just infinitely go. The intention is that this system being a P0 system, right? Even if something goes wrong, we have alerts on this, right? We immediately bring it back if there's any problem. Till date, we have not seen issue where the full system has been down. Degradation, yes, definitely happens. Maybe one or two VMs here go here and there. But the way we have said it is in the app there are retries. That's the first layer of defense that you have. But let's say things do come in, Heimdall is up, but the Kafka is messed up, right? One broker down, it will still manage. Two brokers go down, it is a problem. And currently, what we have said is the availability we have is one broker going down. That is the architecture. And we also have automated setups for these Kafka. Worst case, if something happens, we can just bring up a parallel setup and route things there. During that interim, of course, system is not up, but the app is still buffering data, right? Once it's back, it will just push everything. Web, in web, this is a problematic thing. But the traffic from web is low on the lower end, but there also no, there is some amount of caching within the session. But yeah, if suppose you go out of the session, it is a problem in that case. Yes. No, it doesn't. I mean, it does go down here and there because some things may happen in the VM. But full platform outage has never happened at least. In that case, we Yep. And again, what we have done is all these are automated deployments. Again, there is infra setup. We use Ansible for it. Everything is automated. We can quickly bring it up, provision VMs, bring it up, and load it. But currently, this is one easy. Yes. No, it's not scaled up all the time. The infra costs are massive in this, and sale events of Mintra, we get huge amount of traffic. We cannot keep it permanently scaled up. So, right, we know, I mean, whenever there's a sale event, we see what again, there are expected numbers, right? Like what kind of traffic may come. We see if our system can handle it. If not, we have to, and not if it's a big sale, we have to scale up. We do an in-place scale up. There's a Kafka repartition tool, which will like if you have a topic which is running on say 5 brokers, now you add 10 more brokers, you can rebalance it to all the 15 brokers. Yeah, we scale it. Yes. We have, again, it's not a manual scale up. All of these are automated wherein we tell the system, okay, this is what I want to do. Somebody has to monitor when it's scaling up because it's a critical system, but all these are automated. It's not manual. Now coming to any other questions on the ingestion front? Kafka as a service is a different system, but in that there is an SDK which is provided to all the clients. Yes. It is not REST, it's TCP, direct Kafka client itself. Yes, something, not even, so it's just like a wrapper around the original Kafka client is what is provided there. Yep. Yes, yes. Azure is... I'm aware of it, yes.
But I think the issue also is, I would also talk it from
I think that comes down to ROI. As the cost goes up, there's nothing you can do. So coming to... Yes, that's the error queue what we maintain here. So if, again, here the way it works is two fronts, right? One is in the producing end, if something breaks, we push it to an error queue. In the consuming end, generally, I'll come to that, right? With stream processing, what are some of the things we do? And what are some of the things which is a challenge as well? So I'll come to that. But there's no dead letter queue as such, which we have to do. Schema, no, there is no scheme. Schema discovery is not there. We just know what event the category belongs to. So based on that, we do the mapping. Only for routing, yes. Currently, there is no schema discovery, but we have a common standard schema for all these. So each event cannot come with a different schema, that will not be possible. Again, I'm talking about clickstream ingestion. Airbus is different altogether. Yes. So Kafka does not have a load balancer as such. Kafka client does the job. It knows where to route it to. Heimdall, you have a HAP in front of it, which does all of the load balancing. HAP is there, yes. Azure is more for infra, pretty much. But why do we need it for internal? We wouldn't, right? Yeah. It's more internal, we don't want to use it. This is only because this is the entry point. Directly we can't have the apps communicating with Kafka. I mean, we could put gRPC and all that, but you'll still need something sitting in front, manning right in front before it enters the system. So the next layer is the processing layer, right? Till now we spoke about the ingestion side of it. Coming to processing, one important thing is, again, we went with Spark. I'll come to the comparison as well with what are other platforms we considered. Advantage of Spark is it's well known in the industry, as in there's a lot of community support which is available, one. Second is we have platformized something around Spark. So it's not like everybody goes and writes a custom code and they have to deploy it. So we have our own way to write jobs in Spark, and that particular mechanism has its own versioning, deployment, and all of it. So we have a platform built around Spark, which will, again, it's an in-house platform which has been built. So that way it's easy to build jobs. The second thing is with Spark, it is pretty much scalable. As in, irrespective of the data volume, it will scale up. And even from a cost standpoint, it's not super expensive. The reason is it works with microbatch. It's not true streaming, it uses microbatches. I mean, it has its own problems, but end of the day, cost-wise, it gives you a good trade-off. Next thing is resiliency. Spark has the concept of checkpointing. If something breaks in streaming and you re-trigger a job, it's going to pick up where it left off. So that way you know there is no data loss. Of course, I mean, there can be data duplication based on how we have set it up. But that is still fine. I mean, data loss is a problem, but data duplication here and there is not a big challenge. Next thing with Spark is, again, we deploy them in Spark clusters. And the thing is, Spark has a concept of queuing. So when you deploy these jobs, it is multi-tenant in a way. I can deploy even 10 jobs in a cluster. I can give each of these jobs into a particular queue, and the system will ensure the correct resources are allocated to the jobs. So that will ensure that you don't need to worry about the noisy neighbor problem with Spark. So what we also did is, again, we chose Spark, but again there are alternatives. I mean, I've just put 3 here, right? But if you look at the streaming ecosystem, you will find so many things. There's Storm, I think there's Hazelcast as well, which is another system. So we didn't consider everything here. We had to look at our NFRs first. Because each platform is good at what it does, but we had to see what matches our requirements the best, given what we wanted. So some of the comparisons which we did is, number one is cost, right? Because when you look at real-time use cases, the thing is, if you go to any product manager and you say if you want a real-time use case, they will say yes. So nobody will say no to real-time use cases. But the challenge with real-time use case is the cost which comes with it. Like running a streaming job is very, very expensive compared to running a job in a batch mode. So what that implies is, first we have to look at the cost. Cost-wise, Spark is the best, simply because it has micro-batch. So you're batching data and processing it, which saves cost. Flink, it is definitely higher. It does true stream processing, it's very fast, but you need to give it a significant amount of processing power for it to actually work. K-Streams as well, the cost is high. I mean, K-Streams is very similar to Flink processing-wise. It also does true stream processing. So that way the cost is much higher because it processes all the messages one by one. Coming to latency, Spark is in the range of seconds. I mean, the documentation says milliseconds, but we have tested this in various scenarios. What we have seen is generally it's in the range of a few seconds. Whereas if you look at Flink and K-Streams, even that we tested, the latency is in the range of milliseconds in case of Flink and K-Streams. Now that is very helpful if you want real-time processing. I mean, in milliseconds you want something. In our case, we never felt the full processing has to happen.
Question here.
Sure. So one typical use case, I can take recommendations, right? So if you're browsing for, say, t-shirts. Now, within the session, let's say you're browsing for, say, Nike blue t-shirts. I mean, that's your affinity. So now, the next time you open, it will show you something like similar products. So at that point, now within that session, now a typical user session is around 5 minutes. So normally that's the range. Again, it varies. But typically a user would use it, maybe that's pretty much how long they would use it. So I should be able to, within the session of the user ends, I should be able to give him recommendations which is for that user. Yes, absolutely.
Right, that's one of the concerns, right?
Yes.
Go somewhere else, and that recommendation has to be more repetitive.
Exactly. All of these, I mean.
That's why I'm trying to understand. So then that concern point here, the trade-off that you have of engineering perspective, and whether you invest in a second version or whether
So what we did is, we did these calculations. At least currently what we found is, again, end of the day, all of these are giving input to a machine learning model, right? And it depends on how these models are trained. So when you're training the models, today the models which are trained, maybe with seconds of data, they're performing fine. And with milliseconds, there is no proof we'll get a better result. So we don't want to invest more in the cost when we know there is no ROI for that. Yep. So that is the intention. Again, we went more with Spark. And also some of the other comparisons, which if I have to highly go over, K-Streams is not suitable for complex use cases because it's generally meant for all lightweight kind of a use case. It's written in the application end. High throughput is not a problem. All of them can handle it. Platformizing is a little complex with K-Streams. It's never meant for platformizing. I mean, Flink and Spark are meant to be platforms, but K-Streams, I mean, it was not the intention to be a platform when it was designed. And finally, prior ecosystem. What I mean by prior ecosystem is within Myntra, it's more like batch processing has been done all these years. Near real time is something which recently started, and in batch processing, Spark was already being used. What that implies is the time to learn this, develop it, again, there is a significant reduction. So there is a bias towards using Spark even from that. K-Streams as well, we know, I mean, Kafka also has been used for a significant amount of time. So again, from a prior ecosystem standpoint, Spark and K-Streams is more compatible. So some of the challenges which we see today is the data delivery guarantees. We do not have exactly one semantics. We use something known as at least one's guarantee. Data is not lost, but there may be duplicates if something severely goes wrong with the system. And that is something which is fine. Again, most of the powering is say machine learning models, in which case, even if there is a small data duplication, it shouldn't affect the model performance. Next is the resiliency is, now the problem with streaming is this, right? Imagine if for some reason the Spark job went down for 3 hours. I mean, we normally catch it much before that. But if something happened, the job went down, it's not able to recover. Streaming doesn't work in a way that, okay, I'll just restart my job and it'll backfill all of the data and continue. It just doesn't work that way. Maybe 15 minutes, 20 minutes it'll survive. If your system is down for 2-3 hours, then backfilling is a very, very complex task in case of streaming. And the question is, do you really need a backfill or can you wait for a one-day data which will anyway have what you want? So those decisions are something which we take. And finally, outage recovery, as I mentioned, if the system is down for again, when I say system, I mean only the streaming portion of it, not the ingestion layer. If the system is down for very long, then we make a decision again, is this data worth recovering in this case? Or do we say the data is available in the batch data set and continue with that? Because generally it's not possible to recover beyond a particular time. That's a trade-off which we have to live with in the streaming world. Any questions till now? Mm-hmm. So what we normally, it depends on the kind of use case again, right? There are use cases where, again, every event has a timestamp associated with it. In Spark, we do put a watermark, telling that, again, watermark is an approach in Spark where you're telling if an event exceeds X time interval, ignore it. So normally what we do is we wait, again, the way we have built the platform is even if an older event comes in, it will fit in that bucket and we can recompute it. But there are scenarios where you cannot do that. If you do very complex joins, you will have to adhere to that watermark and skip the late coming records. But the question is that, right, if, I mean, you could process if you want, comes down, again, it comes at cost. Every time you do all these, the cost will keep increasing. The question is it really beneficial to do all that, or should we say this is what the system does, this is the cost it runs at? The timestamp, the incoming timestamp, yes. The Spark job. Any other questions? So, correct. It will, exactly, what happens is when you restart these jobs, it will pick up where it left off. I mean, that's how we have designed it. But the challenge is, streaming by nature is not meant for processing bulk records. It's more for streaming. I mean, that's the whole point of the job. So if I have 3 hours backfill, the streaming job can never backfill it unless you give it extreme compute, which is not worth it. In that case, you can just choose to go with the batch data. We say that the data is delayed for this date, go with the batch data. But what we have done is the system is designed in such a way these downtimes don't happen often. When it does, yeah, we stop it at that point. We say consume from the latest data point. So there will be a loss of data. But the call here is whether, again, these are machine learning models, right? It's not like there's revenue impact. Rather, these are not order data or revenue data which you're losing. we keep a significant ETL for this. Like we know it will process streaming systems. Generally, the data should not be there for more than a few hours. It's pointless beyond that. So we keep a ETL of that much. Ballpark, I would say Link would be almost, from what we have seen, say almost 5x of Spark. Because just to give a illustration, right? If I'm having, say, 50 partitions in Kafka, in Flink, first of all, I need to give it 50 cores in Flink so that it's a one-to-one mapping, one core to one partition in Kafka. And the second thing is, to process data in Flink itself, it's real-time processing, right? You're not batching it. You're losing all those batch optimizations. So that way it's expensive, but the latency difference is also equal like that. This is in seconds, this is in milliseconds. We are seeing that Flink is almost 10x faster than Spark. If you're purely looking at speed, Flink is the way to go. Like if you want that millisecond speed. Yeah, K-Stream also is similar to that because it's code I would say it's real-time streaming, right? You're not doing any batches. So you have to read every record, process it, sync it, and continue with that. And can go back to the main. Yeah. So just to go over this, currently I went over the clickstream ingestion. Server side, I did touch upon it. I didn't go in depth. I went over this whole processing layer. This is the portion I went over now, the Spark processing. State store again, so basically in Spark when you're processing, you need all the state as well. So that is something which we keep in a state store, and that way you can get all of the data back. And finally, coming to the serving side of it, once Spark does all of its processing, it has to dump it somewhere, and then we have to serve it out. So this serving is usually to either machine learning models, or we serve it to any other systems, right, which want to consume it. So that is the next portion which I will be going with. Multi-tenancy here would be, again, this is a platform. I can deploy, say, 20 use cases, 30 use cases. Now, how do I maintain the hardware for it behind the scenes? So, I cannot provision, say, one cluster per use case, which will be very, very difficult to maintain. So, normally, the way we are looking at it is the most optimal way of maintaining these jobs. So, even if 30 use cases come in, we have to maintain 30 jobs. And even if I put them in the same cluster, how do I ensure one job does not break another job running? Or if one job gets a surge of data, right, it should not break something else. So that is the multi-tenancy parameter. Where do you, I didn't get you. No, so the raw events, there's a separate pipeline which I'm not mentioning here. So once it's in Kafka, we have a separate, we dump it to a data lake, all of the data. We'll have to keep that. Final is the serving side of it. So once all of the processing is done, at the end of the day, we are giving these to say, machine learning models is one example. There are multiple things which we serve, like even, but primarily it's meant for say personalization, which means that in real time, you're computing some of the features which go as an input into a machine learning model. What we normally do is we dump this data into Redis. We have Redis clusters. And we have one more Golang service, it's called Tesla, which sits right in front of Redis. And any client application which wants this data, they just call the service and they get it out. But the thing is, this sits pretty much in the user part. So when you're browsing the app, and let's say you want to view similar item, the item similar to a t-shirt, behind the scenes what happens is that service in turn calls a data science API, which tells you, okay, give me the similar t-shirts. That data science API would call this to say, okay, what are the recent things done by a user? And the model will compute what should be shown to the user. So that's pretty much how it looks behind the scenes. Latency here should be sub-millisecond because typically I think the latency for any user-facing application should be under 200 ms. But this is just one service among a chain of microservices. So in that case, the latency here should be sub-millisecond so that the user experience is not affected. And finally, in case of Redis as well, we should not have data loss. So we have a cluster setup of Redis. We have multiple nodes. And in Redis as well, we have replicas to ensure data is not lost. Also, we maintain snapshots in Redis. So if suppose something does go wrong, we can recover data from the snapshot. No, this is in the user part. So your data recovery should be sub millisecond. It's in. Oh, yeah. The throughputs are massive. You're talking. So generally, you will use say RDBMS for something like order part, right? Wherein you need asset properties. So you definitely have to put RDBMS there. But the problem there is with RDBMS, it's more vertical scaling, right? There's an upper bound on how much you can scale it. Here, if sale event comes, the load can go significantly higher. And every request comes to the surveys. It's in millions of requests every minute, what these surveys have to deal with. You mean something like H-based, right, which is file-based? No, the difference is massive. We tested with H-base. We also tested with Redis. With Redis, the read latency, I mean, I'm not at the service level, but just Redis, right? Even if you give it millions of requests, the latency you get from Redis is 1 or 2 milliseconds. So it's pretty efficient that way. So some of the challenges with this system, as I mentioned, the latency should be very, I mean, it's in the user part. You cannot have high latencies here. Second is again, Redis is a data store, which means you have to scale it up and down again during the sale events. What that implies is, even in Redis, we do something known as a resharding of Redis. So similar to what I mentioned in Kafka, right? You have say 5 shards in Redis, I want to make it 15 shards. Two approaches of scaling Redis. One is I repartition the whole data, in which case I have to take my whole data, split it across new nodes and spread it across. Second approach of scaling Redis, if you're only serving is you can add more replicas and scale it that way. We normally do resharding because even the data size increases as during the sale events. And finally, data persistence in Redis, as I mentioned, we have snapshots and we take backups of those. Worst case, if something happens, Redis has a clustered setup, so even if one node goes down, it will still work. If the full cluster goes down for some reason, we do have a backup and we can bring the data back from Redis. That pretty much covers the overall platform, what I wanted to cover. Not each user, it's more per use, not when, I can say per use case there is one Redis, something like that. Not each user, because that would not work out. Like your Redis, again, we are storing massive amounts of data, which is pretty much for the whole user set, which we have in Mentor. Cannot tell exact size. These are in. Okay, so approximately, see what across all our clusters, if I sum it up, these are multiple use cases, not one use cases. So this is in terabytes only, single digit terabytes, not more than that. Yeah. These are all clusters combined. We don't store, again, we have to, the thing with Redis, right, though it's very performant, it has no disk support, right, it's all in memory. So you will have to decide what you want to store. We are very optimal. Again, the way we do is when any use case comes to this platform, the first thing that you look at is ROI. Is it giving the returns that you want? Only then it's onboarded. Because the cost of running itself is very high, right? If there is no, like, it's not a positive use case where you're not getting improvements, then it will be negative putting it in this platform. And then got it. Those we can check. Again, there are multiple systems. Initially, we went with Redis because it ticked all the right boxes for us. So we just went ahead with it. We did compare it with HBase. The only thing we saw there is the latencies were fine overall, but P99 was giving a bunch of problems. Like sometimes it just used to spike up, so we couldn't go with HBase. Yeah, that covers the whole session. Any other questions? No? No. The serving is happening through Redis and the Golang service. Correct. No, it is not Kafka. So the way it works is so the features will go into the Redis service. So that service in turn gives input to a data science model, which is also a service. And correct. That will come from the application. It's more like you want to see the recommendations. You call a recommendation service, right? It's a microservice. That in turn will call this to get the near real-time data. The model will compute what you want and respond back. No, but something has to dump it there. Like it has to sit right in front of the events coming in. See, the one thing is HTTP is simpler to deal with. We could have used gRPC, I think. For scaling gRPC, we can use that. But initially, when this was designed, HTTP was the simplest thing to design, and it was put, and it scales. It's not posed any problem till late. Yeah, that is continuously evolving. As in things like the state store and all that, right? We check the whole system. We see what technologies we use. Is something better? Is it adding value? And we swap it across.
Okay, but that type of issue. What does
These clusters, in the sense, size meaning in what parameter?
Parameters, one is number of nodes it can, number of machines, and the other one is
These clusters, how big would they be? See, these are in Kafka would be in double digits, the number of brokers that we have. But data-wise, as I mentioned, it's in terabytes pretty much. Kafka is double digits, the brokers.
And the other thing, the Spark is
Spark would be massive, as in how many? It would be in triple digits, the nodes. And each node, typically we use something like 16 or 32 code.
We are talking about at least a couple of thousand.
Some pretty much, yes. Not thousand, maybe. I mean, I don't know the exact count. I mean,
Yeah, so that point of coming and makes sense. Okay, so I think we are all. Okay, any last question, probably?
No, that depends on the machine learning model, right? Normally, while creating these models, there are multiple ways to infer what a user has done. So they would take multiple actions. It's not just one or two actions. Of course, if the user does none of those actions, then definitely a model won't have an output. But if you have done even one or two of those actions, then you will be able to infer. No, you don't need to track. What normally happens is, if a user's data is coming in, we compute it. If no data is coming in, you cannot compute anything for that user. But you have historical data for the user. So it's not just like you have only near real-time data, right? So, yeah. Exactly. No, there is a Normally, if user is not logging in, you have only the device of the user, but that can change. So it's a little tricky to get that.
There is no the people who browse the web, for example.
No, that is tricky because it's difficult to map. Your user can log in from multiple devices, right? That mapping is tricky. Yeah.
The intentions. You mean predicting what you next? If we do that,
what?
We're talking about contextual.
Okay. There are multiple use cases on the platform. I don't know all of the use cases which are deployed, but yeah.
Okay, so let's take all the other questions when we formally close it. So I think we are done with the session of today. And thanks to Aditya for this session where we got right double the questions that we have in other sessions. So I would now request Vineet and Aditya to be on stage, our last speakers. And I think Mitesh left. Where is our other Mitra speaker? Is still here? All the speakers, could you please come on stage? So Ashutosh, Srini, the speaker goodies, if you can get that. So then we would request, yeah, go ahead, Vineet, on the stage. Yeah. So, goodies for the speakers. If the speakers are the core, though all the members are core of the community, without the speakers, community doesn't exist because we don't have speakers. Okay. So yeah, go ahead. Super. Thanks, Ashutosh, and all the Milta stalwarts, Srinivas, there's Vardha, Davish, everyone. Means without them, it would have been. Okay, so now what I would like to request all of you, this being Women's Day earlier this week, so it's still a Women's Week. So all the women here, if they can stand in front of the row, then others on the stage, then we can take a group photo, and then we can go the tea and disperse. So thanks once again for everyone. So our ladies first, please be on the first row of the or near the dais, and then others can stand over the dais.